Welcome back to the next section. In this one, we will finally start to build our big course project. And the first step in this project is to build our own API using the most popular Node.js framework, which is called Express. So in the real world, everyone uses something like Express to actually build Node applications, because it makes development a lot easier and also faster. Now, we're still using Node.js, of course, and everything that we learned before still applies. We simply have an easier way of writing Node code. And so that's obviously a big win. So this section is a really exciting one, and so let's get started. So from now on, we are going to use Express in our application. So the logical question is now, what is Express and why should we use it? So Express is a minimal Node.js framework, which means that it's actually built on top of Node.js, basically as a higher level of abstraction. But behind the scenes, Express is written 100% using Node.js code. Okay? It's also the most popular Node.js framework, by the way. There are a couple of others, but Express has kind of become the standard here. So Express contains a very robust and very useful set of features. Things like complex routing, easier handling of requests and responses, adding middleware, server-side rendering, and much, much more are all included out of the box. And this, of course, allows us to write Node.js applications so much faster than before, because we don't have to reinvent the wheel, basically. We don't have to repeat the same code over and over again each time that we need to implement some really complex routing, for example, or some templating system or something like that. So all of that is already included in Express, ready for us to use. For example, remember how we did some extremely simple routing right in the intro section of this course, but it was still not really straightforward to implement it. But with Express, it's going to be like 10 times more simple, you will see. Also, Express makes it easier to organize our application into the MVC architecture, which is a very popular software architecture pattern that we're going to explore during this course. So, in conclusion, Express will make our lives with Node.js so much easier, and the experience really is so much more pleasant. So I can't wait to show it to you throughout this section. Now, before we can move on to writing some actual Express code, we first need to install yet another tool, and this time it's an app called Postman. And Postman is a beautiful tool that allows us to do API testing. It's a little bit like a browser, but it doesn't render any HTML or any visible websites to us. Instead, we can do all kinds of requests and then receive the response simply as text and then work with that response. So as they say, Postman simplifies API development, and that really is true. And it kind of is the standard application that you will see everyone using, basically for testing APIs. But you can do a lot more than just testing, and we will see many of these features throughout this course. For now, just head over to getpostman.com, so as you can see here in the URL, and then here on product, just hit Postman. Then finally download the app, and then download. So I'm not going to download it right now. Of course, I already have it installed. And so let's now take a look at how Postman actually works. So I'm going to open up Postman. That takes a little time. And so here we go. This is how Postman looks like. And probably when you downloaded yours, it's going to be in a light version. But if you like the dark mode like me, just open up the settings. And on themes, you can just use the dark theme over here. All right. So as I said, it's a little bit like a browser where in here we can enter a URL and do the requests. Now it does allow us to do all kinds of requests, where in the browser, whatever we put in here in the URL bar, it's always going to be a GET request. But here we can change that. We can use GET or POST or PUT or PATCH and all these HTTP methods here, where some of them we already talked about before and will keep talking about in this section. Okay. Now, just to test it very quickly, let's use again the doc API that we used before. So that was at doc.ceo, then doc API, and let's just simply use this URL here. Okay, and so all we have to do is to put it here. This case, we really want a GET request and then send. And after some time, it should then show up down here. And indeed, here we go. So that is the JSON data just as we expected it. Okay, so it looks exactly like what we have here, right? Now we can then actually save these requests here, and we can create collections and folders to organize our requests. We can run automatic tests. We can set up different development environments or production environments, and all kinds of other useful stuff, like sending data in the body for a post request or a patch request. Or we can set headers, or really all you can imagine about building APIs. So from now on, in the next couple of sections, we're always going to be using Postman to run our requests. Okay, so this was just a very quick demo of Postman, so that starting now, we can start building our API and then test it using this tool. Welcome back. Let's now finally set up Express, create a simple server, and do some basic routing just to get an initial feeling of how we actually work in Express. And so in this video, we're actually going to start working on the Natours project. So the big main project that is part of this course. So just like before, please go ahead and get the starter project from the course files. So I already have it here, and I have it open up in my VS Code. So let's take just a very quick look at what we have here. So we have the prior configuration file, just like we set up before. I also have a config file for ESLint, and ESLint we haven't set up at this point, but we're going to do that also later in this section. Okay, for now I just want to start coding and not worry about linting our code. So linting is just to fix some errors, but again, we're going to do that later. Then here we have just some files for later, like CSS images. Okay, and now also, for example, some data that we need to build our application. Okay, and again, we're going to start using this data here throughout this section. Anyway, we now have a brand new project, and the first thing that we usually do in a new project is to create the package.json file, just like I mentioned before. So we did that in the node farm project, and now we're going to do that here as well. So I open up the integrated terminal, and you can do that by hitting this shortcut here, or just come here to view and then terminal. So let me put it up a little bit so you can see it. And so remember, the command is npm init. Okay, so we give a name to the project. It's called Natours. Okay, it cannot have any capital letters. So let's do that again. The version is 1. Description, let's just say learning Node Express and MongoDB. Entry point index.js. Well, actually, we're going to use app.js now. So let's call it app.js. We have no task command, no git, no keywords. Author is me. And that's it. So, okay. And so here we have package.json, right? So just like before, nothing new here. So now it's time to install Express. So npm I Express. Now I'm going to use Express 4 here, which is at the point of recording the latest version. But for some time, the Express team has been working on version 5, and so that is a major version which could introduce breaking changes if you installed that one. Now there's actually not a lot of stuff changing in version 5, but to make sure, please install Express at version 4, just like I'm doing. And so in order to do that, just hit at 4. And that will then install the latest version inside of 4. So with the latest minor and patch versions. So 4.16.4. Okay, so that's the version that I'm using now in this course. And yours will probably be a later version, but as long as you have the 4 here in the beginning, you should be fine. All right? So you see that it actually created our node modules folder over here. And so now we're ready to start. So I'm creating a new file, and it's called app.js. So it's kind of a convention to have all the Express configuration in app.js. Okay, and so that's what I'm using here now. So we have now the warning that it can't load ESLint. And again, we're going to configure that later throughout this section. So let's now use Express. And so I'm going to require, of course, the Express package. So nothing new at this point. Give it a save. And you see that Prettier already did its magic here by adding this semicolon and also adding this new line down here. Okay, so we have Express imported. And now what we do is to create a variable called app. So again, that's kind of a standard. So app, and assign the result of calling Express. Okay, and so that's actually it. So Express, so this here is a function which upon calling will add a bunch of methods to our app variable here. Okay, and the first one that we're going to use is actually app.listen to basically start up a server. So that is a bit similar to what we did before with the HTTP package in the previous sections, right? So again, keep in mind that Express is 100% Node.js under the hood, and some of the things work in a very similar way here in Express. All right. Again, it simply makes our lives a bit easier by taking some of the complexity away from us. So just like before, into app.listen, we pass in the port, and let's actually create a variable for that here before. So port, and let's say 3000 for now, and we're going to change that a bit later. So we pass in the port and a callback function. So again, this is the callback function that will be called as soon as the server starts listening. All right. So let's simply do a console.log here, app running on port. All right, so that is our server now actually already listening. Now what we need to do next is to define routes. And once more, we actually already kind of defined routes before in the Node farm project. Remember that, but it works very differently with Express. So remember that routing means basically to determine how an application responds to a certain client request. So to a certain URL, right? And actually it's not just the URL, but also the HTTP method, which is used for that request. So remember that from the HTTP lecture that we had before. So how do we do that? Well, it's very, very simple in Express. All we do is app, then the HTTP method that we want to respond to, and let's start with the simplest one, which is get, and then the URL. And we're just specifying the kind of root URL here. All right? So again, the route is basically the URL, which in this case is just this root URL, and also the HTTP method, which is get in this case. Okay? Now, what do we actually want to happen when someone hits that URL with a GET request? Well, whatever we want to do, we need to specify it in a callback function, which we specify as the second argument. And so we have a callback function. So just like this, and this callback function can accept a couple of arguments. And the most basic one, so the ones that we usually always need, are the request and the response. Okay? And so in that regard, it is again very similar to what we did before in the Node farm project, right? So back then, when we started our server, we also had access to the request and the response object. Now, they are a little bit different here in Express. They have a lot more data and methods on them, but the idea is exactly the same. So you see that Express apps, and so also Node apps for that matter, are all about requests and responses, simply because that is how the web actually works, just as we learned in the previous sections, right? So what do we want to do now? Well, all we want to do is to send some data back very quickly. So we can use the response object, and on there we can use the send method and specify something that we want to send back. Hello from the server side. So just some string again that we want to send back. We can also specify the status code, and that's very easily. All we have to do is to, before we actually send this string to the client, we just add status before that. So the status method. And in here we specify our code. And again, we're going to use 200 for OK. And so that's actually all we have to do. So let's very quickly test this out and then add some more stuff to it. Okay, so let's use nodemon app.js. Let's see what happens. And our app is running on port 3000. Great. And how do we now test this API? Well, that's why we installed Postman, right? So let's open up Postman. And actually it's still here from the last lecture. And so let's go ahead and delete this and write the URL, or actually the IP, for the localhost, and then our port. So that is exactly the same as we did in the node farm project, right? And we're hitting just the root. And so we can write this slash, or it works just the same without anything. So let's send this. And indeed, here we go. Hello from the server side. So that's amazing. It already works. And just to make sure, we would of course get the exact same result in the browser. So if I copy this here, you will see the same result. Okay, but again, we're going to use Postman because it makes all this API testing a lot easier for us. Okay, and you will see once we really start using more and more features of this great application. All right, now going back here, let's add some more stuff, because send simply sends this string here back to the client, but it's also very easy to send JSON to the client. So instead of using send, let's actually use JSON. So the JSON method, and then in here we can pass in an object. So let's do it like this, so let's say this is the message, and then just some other field here, Natours. Okay, and so now you see that Prettier here auto-formatted this for us, and I also want this in another line. Okay, we're missing the comma here, of course, but the Prettier extension still put it up here for some reason. But of course, that doesn't really matter. It's just a matter of formatting. Okay, so let's take a look at what happens now. And so now we have our nicely formatted JSON here. It gives us all these different colors here for the keys and for the values. Here we have the status code. Here we have the time it took to do this request. And we also have the size of the response. We could, for example, change the code here very easily. So 404 is not found, remember. Do it again. And then here you see 404 not found. So that's the kind of stuff that Postman is really great for. Let's actually increase the size of all this. Okay. And so let's now continue. Just add something else here. Just something very easy. Remember, all of this is just to test it out, to get our feet wet and start getting a little bit of experience. So remember that this here is the HTTP method for the request. Okay. And so this response that we're sending here, so this one here, is only sent when a get method, so this get method is sent to our server on this URL. Okay, and let me actually show it to you. So if we do, for example, a post, and that's very easy again with Postman. So if we do post, then we will not get anything. Instead, what Express automatically sends back is this HTML here, which says cannot post, and then with a 404 not found. And that's because we don't have any route defined for this URL and for this HTTP method. Okay, and so let's now very quickly do that. So post, we want the same URL, the request and the response object, and let's simply say res.send. You can post to this URL or to this endpoint. Okay, so just so you see that this is how we send different responses for different HTTP methods in the request. So let's run that again. And indeed, you can post to this endpoint with a 200 status code. So this is actually the default one when we do not specify any in our code. Okay, so here we have 404, which is not correct. But again, 200 is actually the default. Another quick thing that I want to show you is that by using this JSON method here, for example, this will automatically set our content type to application JSON. So remember that we did that manually in the Node Farm app when we created our very simple API. So back then, we also sent back some JSON, but we then had to manually define that the content was JSON so that the browser knew what it was expecting, right? But Express takes that work away from us. And let's actually check that. So going back to get, so here we have our result headers. And so here you see that the content type is indeed set to application JSON. Express then also automatically sends a bunch of other headers, for example, this powered by Express, or the date, or the connection. Okay, but again, we're going to take more care of headers a bit later in the course. So this was just a very small and simple example here, but you can already start to appreciate how much easier it is to do this kind of responses. So to create this route in order to respond to client requests in a much easier way than in just plain Node.js, right? And with that being said, in the next video, we're going to learn all about building APIs using the REST architecture so that after that, we can finally start building our API. So now that we know what Express is, we're almost ready to start building our API. But before we do that, I need to quickly talk about APIs on a higher level, and more importantly, introduce you to the REST architecture, which is the most used API architecture today. This way, we will actually know what we're building. So it's extremely important to understand the stuff in this video before moving on, so that we actually know what we're building throughout the rest of the course. So first of all, API stands for Application Programming Interface. And on a very high level, it's basically a piece of software that can be used by another piece of software in order to allow applications to talk to each other. So we have actually talked about APIs before, more specifically web APIs, where we simply build an app that sends data to a client whenever a request comes in. So imagine we have our app running on a server and we have a client. And so in fact, we effectively have two pieces of software talking to each other, right? And this is the kind of API we will build in this course. And I guess it's the most widely used type of API out there. But in fact, APIs aren't only used to send data and aren't always related to web development or JavaScript. So the application in API can actually mean many different things as long as the piece of software is relatively standalone. Take, for example, the Node file system or the HTTP modules. We can say that they are small pieces of software and we can use them, we can interact with them by using their API. So for example, when we use the read file function from the FS module, we are actually using the FS API. And that's why you will sometimes hear the term Node APIs. And that usually simply refers to the core Node modules that we can interact with. Or when we do DOM manipulation in the browser, we are not really using the JavaScript language itself, but rather the DOM API that the browser exposes to us, so it gives us access to. Or even another example, let's say we create a class in any programming language, like Java, and then add some public methods or properties to it. These methods will then be the API of each object created from that class, because we're giving other pieces of software the possibility of interacting with our initial piece of software, so the objects in this case. So you see, API has actually a broader meaning than just building web APIs, alright? Anyway, a web API is what's most important for us in the context of Node. And so let's now take a look at the REST architecture to build APIs. So REST, which stands for Representational State Transfer, is basically a way of building web APIs in a logical way, making them easy to consume. Because remember, we build an API for ourselves or for others to consume, okay? And so we want to make the process of actually using the API as smooth as possible for the user. Now, to build RESTful APIs, which means APIs following the REST architecture, we just need to follow a couple of principles. First, we need to separate our API into logical resources. These resources should then be exposed, which means to be made available using structured resource-based URLs. To perform different actions on data, like reading or creating or deleting data, The API should use the right HTTP methods and not the URL. Now, the data that we actually send back to the client or that we receive from the client should usually use the JSON data format, with some formatting standard applied to it. Finally, another important principle of REST APIs is that they must be stateless. So this is a very broad overview. Let's now start talking about these principles one by one, starting with resources, and using the Natours API that we're going to build in this course as an example here. So the key abstraction of information in REST is a resource, and therefore all the data that we want to share in the API should be divided into logical resources. Now, what actually is a resource? Well, in the context of REST, it is an object or a representation of something, which has some data associated to it. For example, tours, or users, or reviews, in the case of the example that we're following. So basically, any information that can be named can be a resource, alright? It just has to be a name though, not a verb. Now, we need to expose, which means to make available, the data using some structured URLs that the client can send requests to. For example, something like this. So this entire address is called the URL, and this add new tour is called an API endpoint. So our API will have many different endpoints, just like these fictional endpoints that I have here, each of which will send different data back to the client, or also perform different actions. Now, there's actually something very wrong with these endpoints here, because they really don't follow the third rule, which says that we should only use HTTP methods in order to perform actions on data. So endpoints should only contain our resources and not the actions that can be performed on them, because that would quickly become a nightmare to maintain. So how should we use these HTTP methods in practice? Well, let's see how these endpoints should actually look like, starting with getTour. So this getTour endpoint is to get data about a tour. And so we should simply name the endpoint tours and send the data whenever a GET request is made to this endpoint. So in other words, when the client uses a GET HTTP method to access the endpoint. And just like this, we only have resources in the endpoint or in the URL and no verbs, because the verb is now in the HTTP method, right? And by the way, it's a common practice to always use the resource name in plural, which is why I have tours here and not tour. Now, the convention is that when calling that endpoint, we get back all the tours that are in the database, okay? But if we only want the tour with one ID, let's say 7, we add that 7 after another slash or in a search query. Or it could also be the name of the tour instead of the ID, or some other unique identifier. The detail doesn't really matter at this point, alright? Later, I will show you how easy it is to actually implement this kind of logic with Express, because this is actually where Express really shines. So, the first HTTP method or verb that we can respond to is get, and it's used to perform the read operation on data. Next up, if the client wants to create a new resource in our database, in this example a new tour, the post method should be used. So we learned earlier that a post request can be used to send data to the server, and so it makes sense to use post in order to create new resources, right? Now in this case, usually no ID will be sent because the server should automatically figure out the ID for the new resource. Anyway, what's really important to note here is how the endpoint name is the exact same name as before. So the only difference is really the HTTP method that is used for the request. So if the /tours endpoint is accessed with get, we send data to the client. But if the same endpoint is accessed with post, we expect data to come in with the request, so that we can then create a new resource on the server side. So that is really the beauty of only using HTTP methods rather than messing with verbs in the endpoint names. Again, that would really become unmanageable very quick. Alright, next, there should also be the ability to update resources. And for that, either a put or a patch request should be made to the endpoint. The difference between them is that with put, the client is supposed to send the entire updated object, while with patch, it is supposed to send only the part of the object that has been changed. But both of them have the ability to send data to the server, a bit like POST actually, but with a different intent. So POST is to create a new resource, while PUT or patch are used to update an existing resource, and so that makes all the difference. And finally, to delete a resource, there is the delete HTTP method. Again, the ID or some other unique identifier of the resource to be deleted should be part of the URL. Now, usually, in order to actually be able to perform this kind of request, the client must be authenticated. So basically logged into your app, okay? But that is, of course, a topic for much later. So these are the 5 HTTP methods that we can and should respond to when building all RESTful APIs, so that the client can perform the 4 basic CRUD operations. So CRUD stands for create, read, update, and delete. And you will see this term all the time related to APIs and database stuff. And you see that these HTTP methods map quite nicely to the basic CRUD operations. Now, there might be actions that are not CRUD. And in that case, we just need to get creative with our endpoints. For example, a login or a search operation. These are not really related to a particular resource, and they're not CRUD operations either, but we still can create endpoints for them, for example like /login or /search. But we'll talk more about these cases later in practice. And just to finish this part now, remember that we had 2 other crazy endpoint names in the last slide, which kind of involve 2 resources at the same time, right? And that's also no problem at all with REST. So getTours by user can simply be translated to users/tours. In this case, user number 3. So this particular endpoint here could send data about all the tours that user number 3 has booked. Make sense? Or in the case of deleting, there could be a delete request to the same or a very similar endpoint requesting tour number 9 to be deleted from user number 3. Okay? So there really are a tons of possibilities of combining resources like this. But of course, we don't have to implement all these combinations in our API. We only implement what makes sense in the case of our application and the client that wants to consume our API. So, this is how we make use of HTTP methods to build user-friendly and nicely structured URLs that are easy and logical to consume for the client. Now, about the data that the client actually receives or that the server receives from the client, usually we use the JSON data format. And so let's briefly learn what JSON actually is and how to format our API responses. So JSON is a very lightweight data interchange format which is heavily used by web APIs coded in any programming language, so it's not just related to JavaScript. And it's so widely used today because it's really easy for both humans and computers to understand and write JSON. So you're probably already noticing that JSON looks a bit like a regular JavaScript object, right? With all these key value pairs. There are, however, some differences, and the most important one is that all the keys have to be strings. It's also very typical for the values to be strings as well, but they can be other things, like numbers, true, false values, other objects, or even arrays of other values. So it's quite straightforward actually, and from this example, you can kind of see how some typical JSON might look like. So let's say that this is the data that we have in our database for a GET request to this URL, so the tour with ID of 5. Now, we could send it back like this to the client, but we usually do some simple response formatting before sending. There are a couple of standards for this, and we're going to use a very simple one called JSend. So we simply create a new object, then add a status message to it in order to inform the client whether the request was a success, fail, or error, and then we put our original data into a new object called data. Okay? And we can develop this even a bit further, but this is really the simplest way of formatting with JSend. And just by the way, wrapping the data into an additional object like we did here is called enveloping, and it's a common practice to mitigate some security issues and other problems. Also, there are other standards for response formatting that you can look into, like JSON::API or the OData JSON protocol. Alright, and finally, a RESTful API should always be stateless. So what does stateless actually mean? Well, in a stateless RESTful API, all state is handled on the client and not on the server. And state simply refers to a piece of data in the application that might change over time. For example, whether a certain user is logged in, or on a page with a list with several pages, what the current page is. Now, the fact that state should be handled on the client means that each request must contain all the information that is necessary to process a certain request on the server. Alright, does that make sense? So, the server should never ever have to remember the previous request in order to process the current request. So let's take the list with several pages as an example. And let's say that we're currently on page 5 and want to move forward to page 6. So we could have a simple endpoint called tours/nextPage and submit a request to it, right? But the server would then have to figure out what the current page is and based on that, send the next page to the client. In other words, the server would have to remember the previous request. It would have to handle the state server side. And that is exactly what we want to avoid in RESTful APIs. Okay? Instead, in this case, we should create a tours/page endpoint and pass the number 6 to it in order to request page number 6. This way, we would handle state on the client, because on the client, we would already know that we're on page 5. And so all we had to do is to just add 1 and then request page number 6. So the server doesn't have to remember anything in this case. All it has to do is to send back data for page number 6 as we requested. And by the way, statelessness and statefulness, which is the opposite, are very important concepts in computer science and application design in general. So it's a good idea to actually have some understanding what a stateless API is and how it works. Anyway, this was a huge lecture, but also one of the most important ones. I cannot stress that enough, and I actually think that you can see that, right? Anyway, let's now finally get back to our code. Welcome back. So now the time has come to finally start building our API. So this lecture is really going to be the first step in a long journey of building this main course project. And let me actually start by showing you again the project that we're talking about. So this is the Natours project. It's basically an application where we can see tours and also book them. We can create user accounts, we can log in, and really do all kinds of different stuff. So for example, we can take a look at the tour here. It has all these details, this map. It has reviews from other users that are using the platform, and we can even book the tour then. We would have to log in before we are able to book, and I'm not going to do that now because it's just a very simple demo here. So I just wanted to show you this graphical interface, basically, of the project that we are building. Now this part that you're seeing here is actually the part that we're going to build by the end of the course, because this first part of the course is to build an API using the exact same data that you see here on this dynamic website. So again, we start by building the API and then the dynamically rendered website. And I choose to do it like this because this way we don't have to mix all these different concepts all together. So in order to learn Express and Mongo and Mongoose, I find it much easier to just work with data and not worry about the graphical stuff. Even though that's maybe a bit more exciting because you get to see the real results in this beautiful interface, but to learn it's better to, again, simply just deal with the data itself and worry about making it beautiful later. Okay, so let me actually show you the API as well. And for that, of course, I use Postman. Create a new tab here. And so the final API we access at /API/version1. And then, for example, we can take a look at tours. So we use the GET request, and then we get all of these different tours, right? So again, the exact same tours that you saw on the graphical interface, so on the rendered website before. Okay, we can then also go ahead, take the ID, and request only that ID, so only that tour for that ID. And so you see that now we only have this one here, with even more data than we had before. So we have start locations here, we have tour guides, which in turn has other IDs. We have locations, we have reviews. So all of that we have in a tour. So you see, it's really advanced stuff. And so we actually have more than just tours. We have users, but we will not be able to access them because we need to be authenticated. So you're not logged in. And so right now we would need to log into our app. Now at this point, I'm going to stop showing you all the features because we will build this throughout the course, just to show you that there is really a lot going on here. And so there is a lot of material and of stuff to learn ahead of you. So I hope you're excited for that and that you want to take the first step with me right now. So let's go back and implement the tours route, or starting to implement it at least. Okay, so this piece of code here we no longer need, and I'm not deleting it, just commenting it out. So again, we use app.get, because in this lecture we're going to start by just handling the get request. And the URL will be /API and tours. So I'm not using v1. Well, I could use v1 right away. So it's a good practice to specify the API version, okay? So that in case you want to do some changes to your API, you can do that, but simply then on v2 without breaking everyone who is still using v1. Okay, so basically you can branch off, create a new version of your API, but old users can then still be using it. If we did it just like this, and you did changes then to API/tours, then the users who started to use it before you did the change would run into some problem. Okay, so we always should specify the version of the API. We could also do it in a subdomain, but it's easier to just simply include it in the URL. Okay, and then of course, or route handler. So this is how we usually call this function. We call it the route handler. Okay, so just to get familiar with these Express terms. Now, what do we want to do when someone hits this route? Well, we want to simply send back all the tours. So that is similar to what we just learned in the last lecture, right? We have this URL or this endpoint /tours, and that will usually send back all of the data for that resource, right? So also tours is the resource now. And I'm starting with tours here because it's, well, I would say the most obvious one since we're building a website or a web application for selling tours, right? Now, where do we actually get these tours that we want to send back to the client? Well, it's here in the dev data folder, then data, and then tours, simple. So it's this JSON file, and it's very similar to the one that we had for the node farm. So again, it's an array of JSON objects, which then has a bunch of data about each of the tours. And so, yeah, that's the data that we're going to be sending to the client. Now, before we can send the data, we actually need to first read it. And so, again, we don't do it inside the route handler, but we do it before. Okay? And just like I explained in the previous project, we can do that because the top level code is only executed once, which is right after the application startup, right? And now that you know all about the event loop, it makes even more sense for you at this point, right? So only this callback function, for example, here will run inside the event loop. And so in here, we cannot have any blocking code, but outside it is no problem at all. So let's simply read the tours into a variable outside of all of this in a synchronous way. So fs, and for that, of course, we need to require the module actually. And so we do that here at the top. And I like to always start with the core modules. And so I do that at the first one. So require fs. So fs read file sync, it's already here. And now let's use the dir name. And so again, at this point, you already know why we actually have access to this variable here. So dir name is the folder where the current script is located, and so that is this main folder. So from here, we need to move into dev data, then into data, and then in there we have tours simple.json. Okay, and now let's also write in this step here, parse the result of this. So JSON, actually the uppercase one, so JSON.parse, so that the JSON that we have in here will automatically be converted to a JavaScript object, or an array of JavaScript objects, actually. So saving it, and so this will reformat it. And so now all we have to do is to really send it back to the client. So res.json, and let me actually specify the status code here. Even if 200 is the standard, I like to do it in each and every single response. All right, so JSON, and what do we want to send back now? Not message, that's for sure. So what do we want to send back? Well, remember that we were going to use the JSON formatting standard. Okay, and so in there we specify a status. So status, and that can either be success, fail, or error. Okay, so success is obvious. It's when we have a 200 code, or 201, or really just any code that starts with 200. Then we have the fail, which is an error at the client. And then we also have error when there was an error at the server. All right, but we are going to use these a bit later. Anyway, we also have then the data property, which is, as I mentioned, the so-called envelope for our data. So we specify the data property, and that data will then in turn have an object, which then contains the data, so the response that we actually want to send. And in this case, that is tours. So tours, and then tours, which is the same name in this case. So with ES6, we actually do not need to specify the key and the value if they have the same name. So we could just write tours. But I just wanted to specify it here that I wrote tours here because, well, that is the name of the resource and of the endpoint. And so that's why inside of data, I then send back an object that has the tour property. Okay, so if this was called X, for example, then I would call this one here X, but here I would still need to say tours. Okay, I'm putting it back to tours because that makes more sense. And now I can delete this here and just leave it like this. And that is actually all we have to do. So we read our data and then we formatted our response like this here using the JSON data specification. Okay, so very simple stuff. Let's now just test it out. And we now have to change, of course, the URL. So we have /API/version1 and tours. So that is our URL. We still do a GET request. Okay, so that's the one that we are responding to in code. So remember using this GET method. And so hit send. And indeed, here we go. So here we have all our tours. So awesome. That's really cool. Really, really nice work. Now, just to finish, something else that I like to do usually when we are sending multiple responses is to include a field called results with the number of results that we are sending. Okay? And this is not really part of the JSON specification, but I still really like to do it because that makes it very easy for the client to get a very quick information about the data it is receiving. So we know that tours is an array, and so all we have to do is to say tours.length. Okay? And this actually only makes sense whenever we are sending an array, so multiple objects. If we only were sending like one tour, then it wouldn't make sense to have results set to 1, right? And so I only do this whenever we're sending an array with multiple objects in there. So let's do that again. And indeed, we have 9 results. Then we have the data property, then in there tours to specify that we're sending tours, and then an array with all the 9 tours in there. So you see another object, and another one, and all the way to the end. So that is the very first step to our API. Of course, this is, at this point, it's like a file-based API. So we're reading this data from an API, but later, of course, we're going to store this data in a database and then read it from there. But anyway, this already looks kind of real, and that for sure makes me feel really good. And I hope it makes you feel good as well. So that's it for the GET request. Next up, we're going to take care of the POST request so that we can actually add a new tour to our data. Let's now implement a route handler for POST requests so that we can actually add a new tour to our dataset. And so just like with the GET request handler, let's start by adding a new route. So app.post this time. And remember, now we use post, so the post method here, because, well, that's the kind of request that we want to handle. So requests that are made with the HTTP post verb, right? So v1 and tours. And so just as we talked about in the REST API lecture, the URL is actually exactly the same. So no matter if we want to get all the tours or if we want to create a new tour, the URL is exactly the same. The only thing that changes is the HTTP method that we use for doing these requests. So get to get all the tours, and post to create a new tour, right? Then in here, our typical callback function, where we get access to the request and to the response object so that we can get some data from the request and send back an appropriate response. Now, remember that with a post request, we can send data from the client to the server, right? And this data is then ideally available on the request, okay? So the request object, again, is what holds all the data, all the information about the request that was done. And if that request contains some data that was sent, well, then that data should be on the request, right? Now, out of the box, Express does not put that body data on the request. And so in order to have that data available, we have to use something called middleware, okay? And we're going to talk in great detail about middleware in a couple of lectures. But for now, in order to make this work, we need to include a simple middleware here at the top of the file. So actually right here. And what we need to do is to say app.use and then express.json. Okay, and that's it. So again, this express.json here is middleware. And middleware is basically just a function that can modify the incoming request data. So it's called middleware because it stands between, so in the middle of the request and the response. So it's just a step that the request goes through while it's being processed. And the step the request goes through in this example is simply that the data from the body is added to it. So it's added to the request object by using this middleware. Okay? So we use app.use in order to use middleware like this. All right? And again, we will talk a lot more about middleware a bit later in this section. For now, just know that this is how we use middleware. Okay? And all the details will then follow later. So for now, just to start, I want to actually show you the data from the body in the console, just to verify that it actually works. And so, rec.body. And so again, body is the property that is going to be available on the request because we used that middleware a couple of moments ago, right? So we want to log rec.body to the console, and then we also need to send back a response. So res.send, and for now just some placeholder here. Just done, okay? So we always need to send back something in order to finish the so-called request-response cycle, which again, we're going to learn a bit more about later in this section. So let's now test this out and create a new request for the post. Now here in Postman, we can do something really nice, which is to save all of these requests. All right, so I'm going to start by creating a new collection, which I will call Natours. So new collection, and now I will save this request inside that collection. So this one is get all the tours. Put it into Natours and save. And so now we have our get request right here. All right. So let's now copy this one here, create a new one. And so this one is a post request. And before doing it, I will actually also save it right to this collection. So create new tour. Okay, and so here on the left side, we now have both of our requests, right? So let's now actually specify our body here. So the data that we basically want to send to the server. So we come here to body, and there are different ways of doing it now, but the easiest one is to simply say raw and then application JSON. And so all we have to do here is to basically specify some JSON, and that will then get transmitted to the server. So the first thing we want to specify is the name of the tour. And remember that in JSON, everything has to be in quotes, and actually double quote, not just any quotes. So let me just call this one the test tour. And let's take a look at what else we have in the tour data. So we have the name, we have the duration, and let's just put also the difficulty. Okay, so I'm not going to specify all of these because that takes way too much time. Let's just say the duration is 10 days and the difficulty is easy. Okay, so that is our body that will be transmitted to the server. So let's test that out now, hitting send, and here we get back our response, which is done, remember. And so here's the response that we sent, so done. And you see that down here in our console, we now have an object which is basically the JSON that we sent in our body, right? So perfect, it works. It is no longer JSON, as you can see, it is really a JavaScript object. And just to show you that we really need this middleware, let's comment this one out, send it again, and so now we no longer have the request.body, right? So that's why it's undefined now, because it no longer exists. So give it a save, send our request again, and so now it's back. All right. So we have our post route all set up, it's working now, and we also get access to the body. And so what we want to do now is to actually persist that data into this tour's simple JSON file. All right. So we're actually going to modify this file so that the data is saved to our fictional database here. Okay. So this JSON file right now kind of works as our fictional database. Okay. And so let's now take care of that. So I'm going to go ahead and comment this one out. And so let's get started. And the first thing we need to do is to figure out the ID of the new object. So remember, again, in the lecture about REST APIs, is that when we create a new object, we never specify the ID of that object. The database usually takes care of that, okay? So a new object usually automatically gets its new ID. Well, in this case, we do not have any database. And so what we're going to do is to simply take the ID of the last object and then add one to that. Okay, so let's do that very quickly, and that's just basic JavaScript. So new ID, it is the tours, right? So remember that tours, we already have the data in this tours variable, right? So that's an array of all the tour object. And so we want to get the last one, which is tours.length minus 1, then the ID property of that, and we add 1. So that is the new ID. Next up, we create a new tour, and that tour will basically be the body that we sent plus the new ID that we just created. Okay, and so we can use object.assign, which basically allows us to create a new object by merging two existing objects together. So the first object is going to be ID is equal to new ID, and then we want request.body. Okay. Now we could also had done request.body.id equals the new ID, but I did not want to mutate the original body object. Okay, and so I just left it like this, right? So that is the new tour, and now what we want to do is to push this tour into the tour array, right? So tours is the array of the 9 tours that we have at this point. And so we say push and push the new tour in there. Okay, so that is the array which now has the new tour in it, but of course now we have to persist that into the file. And that again is quite easy for you at this point. So we use fs.write file. And now which one should we use? So write file or write file sync. And the answer for that is very simple. So we are inside of a callback function that is going to run in the event loop. And so we can never ever block the event loop. And so what we're going to do is to use write file and not the synchronous one. So we want to pass in a callback function that is going to be processed in the background. And as soon as it's ready, it's going to put its event in one of the event loop queue, which is then going to be handled as soon as the event loop passes that phase. Remember that from the event loop lecture? Anyway, let's get the file name from up here, because we will really override this file so that when we restart the server, it's then going to be there. Okay, so so right here. So that is the file where we want to write to. Then the data that we want to write, which is tours. And then our callback function, which in this case only has the error. Okay, and here I just noticed that we need to also stringify this object, right? So we want JSON in this JSON file, and this right now is just a plain normal JavaScript object, and so we need to convert that. But that's again simple. Already did that, so that's JSON stringify of the object. Okay, so what do we want to do as soon as the file is written? Well, what we usually do is to send the newly created object as the response. So let's do that. So response, and then as always, we start by specifying the status code. And in this case, it's not going to be a 200, but a 201. So 201, which means created. So 200 stands for OK, 201 stands for created, which is exactly what happened here. So we created a new resource on the server. So JSON, and it keeps adding this message here. So status is again success. Then I'm not using the results property here that we had before, because now I'm only sending back one result. So data is our envelope here, and then tour is new tour. And that's it. Give it a save here. And so that formatted or code a little bit. Let's add some more space here. And yeah, I think we're ready to now give it a try. So we can actually create a new tour using this data here. So adjust this test tour and with this data, and so let's wait for it. And what happened here? Let's see. Okay, we have a problem that we sent a response twice, basically. So we sent a response here with JSON and then again with .send. And that's not allowed, and that's actually why we get this error here. So it's actually nice that it happened here so that you know what this kind of standard error here means. So HTTP header send cannot set headers after they are sent to the client. And so that happens when you try to send two responses. All right, so we need to get rid of that. Yeah, so that was the only error that we had. And so, yeah, that should now fix it. Give it a try. And indeed, here we go. So we have our ID of 10, which our code created for us, and then the entire tour, which is exactly the data that we sent as a body in our request, right? Now, the thing is that when we do get all tours here, it will not yet show up. So if we go down here, oh, actually it is already here. So we have the one from before. So when we had that error, it actually also created this tour here. And then of course the tour that we just created with the ID of 10. So this tour here is exactly this one that was created right now. So if we do now test tour 2 with a duration of just 5, let's give this one a try. And if I now do get all tours, then that shows up here as well. And I said in the beginning that it wouldn't work, so that it wouldn't show up right away, because this only works if we restart the server, right? Because this file, so the toursimple.json file, where our tours are coming from, is only read at the beginning when we start the server, okay? Now the thing is that each time we save something to this JSON file, it will also reload the server. And let me prove that to you. So if I hit now save, then look what happens down here. So I save it, and so you see that down here it restarted the server. It also formatted the code because of prettier, but what matters here is that this code updated. And that's why each time we save something here with our API, it will then immediately reload the server and will reload the content from the file into the tours, and we can then read that right away. Okay, and so that's why we have access immediately to all the newly created tours. Okay, makes sense? Well, if not, please feel free to just ask your questions in the course Q&A section. All right? So in this lecture, you're going to learn an easy way of defining parameters right in the URL, how to then read these parameters, and also how to respond to them. Now, what we want to actually implement in this lecture is a way of getting only one tour. So right now we have this endpoint here, which gives us all the tours, and we want to have something like this. So let's copy it into a new request for now, and then we want slash and then the ID of the tour. So for example, let's say 5, okay? So this is just like we talked about in the REST API lecture, where I said that if we hit this endpoint without any ID, so just like this here, well, then we would get all the tours. But if we would specify an ID after that, so just like this, and of course it doesn't have to be an ID, it can be any unique identifier, but in this case, the easiest way of implementing it is to just use IDs, okay? So this here is of course a variable, because it can be 5, but it can also be anything else. And so this piece of the URL here, so this here, this is a variable, okay? And so what we need to do is to define a route which can accept a variable. All right, and so let's do that here, actually right after this one. And I'm just gonna go ahead and copy it, because you already know how to write it at this point. And so, yeah, so here we have the route. And so now all we need to do is to add that variable. And that's very easy. So we have our slash again, and then the variable, we define it using a colon like this. And so like this, we created a variable called ID. It could of course be anything else, like var or x, doesn't really matter, but this one is called ID. All right, now we don't want to send back anything like this, so let's just comment it out. And what I want you to take a look at is at console.log rec.params. Okay, so request.params is where all the parameters, or all the variables that we define here are stored. Okay, so these variables here in the URL are called parameters, and again, they are in rec.params, available for us to use them. So let's take a look now and actually do this request. And for now, it's not going to do anything, so it will not give us tour number 5 automatically, of course. But what I want to do for now is to just take a look at rec.params. And so indeed, here we have ID is 5. So request.params is a very nice object which automatically assigns the value to our variable, so our parameter that we defined. And we could actually define multiple. So we could say ID, and then we could say X, and we could say Y, and then we of course would have to define all of them. So 23 and 45, let's say, send this guy, and then indeed we have an object with all these 3 variables in them. Okay, now if we define them like this in the URL, we actually have to then specify them. So if we didn't have the Y parameter, we would run into an error, because we are now not hitting this exact route. Okay, so our route is now no longer exactly this, but it's only this. And so there is an error. Okay, makes sense? Now there is actually one thing that we can do, and that is optional parameters. So if you want to make this parameter optional, we just add a question mark to it, and now it is optional. So we no longer have to specify it. So just like this. And so now we only have 5, 23, and then Y is still here, but it's undefined because it's now optional. All right, but let's get rid of all of this, because we only really need the ID, okay? And so now all we need to do is to actually get the tour with this ID from our data.json, from our JSON file, right? So basically from the tours array. And so that shouldn't be all too hard. And so let's say const tour is equals to tours.find. And I'm not sure if you're familiar with this find method here. So once more, this has nothing to do with Node or Express. It's just a regular JavaScript function which we can use on arrays. And the way it works is this. So in here, we pass a callback function. And so let me actually start by writing that one out. So element ID equals the rec.params. Okay, so it will basically loop through the array, and in each of the iterations, we will have access to the current element, and we will return either true or false in each of the iterations. Okay, now what the find method will then do is that basically it will create an array which only contains the element where this comparison here turned out to be true. Alright, and in this situation, we want to find the element where the ID is equal to the one that we get from the parameters. And so by specifying this callback function here with this comparison, we will ensure that only the element where the ID is actually equal to the specified ID in the parameters will get returned from the find method and stored into Tour. Alright, now actually this is not going to work like this, because as you see down here, these values here, they are actually strings. Okay, so we need to convert that to a number, but that's very easy. All we have to do is to say the ID is equal to rec.params.id times 1. So this is a nice trick where JavaScript, when we multiply a string that looks like a number, when we multiply that with another number, it will then automatically convert that string to a number. So that's a very small, nice trick that we can use here. And so now we already have our tour ready to send. And so the data that we want to send is tours equal to tour. Or actually, it's just tour. So tour should be equal to tour. All right, makes sense? So maybe the most complicated part here is just this one. But yeah, that is again just the normal JavaScript. And so I believe, or at least I hope, that you're already familiar with using this kind of array methods. All right. So we only want tour number 5. And so let's take a look if it actually works. And well, it didn't. So let's take a look at that. Oh yeah, indeed. Here we need to use the ID, of course. So not rec.params. ID. Okay, so try that again. And now indeed we have the tour with ID of 5. Okay, and only that single tour. Let's try number 2, for example, and indeed ID 2. But now let's try another situation. Let's do ID 23. And so now we get nothing back, right? And that's because there is no tour with the ID of 23. But we still return the 200 OK status code. And so that doesn't make much sense, okay? And so let's actually go ahead and change that. And what should we do here? Well, as a very simplistic solution, what we can do is to check if the ID is larger than the length of the tours array. And if it is longer, well, then we can send back a 404 error saying that we could not find any tour for the given ID. So let's do that very simple solution because, well, this is not the real API that we're building at this point. And in this case, it's not a problem to use an overly simplistic solution like that because this is not the real thing that we're building here. We are really just trying to get familiar with the way that Express works. And the same thing can actually be said here. For example, when so down here where we post a new tour, in the real world, we would always have to check if the user input is valid. So if it doesn't contain any malicious code or really anything that we don't want in our app. And again, we're going to do that, of course, later. But in this small example here, I really just want to focus on the fundamentals. Okay, so let's quickly implement what we were just saying, which is that if the ID is greater than tours.length, so for example, let's say we have 12 tours in our array, well, if the ID is then 13 or 15 or whatever, well, in that case, the ID is not valid. So we say return, and that's because we want to exit the function right at this point. Okay, and so that's why we say return. Then we send the status of 404 because we couldn't find any tour for that ID. And then a simple JSON response with the status of fail. So fail is what we send whenever we have a 400 code. And then just a message property, invalid ID. All right, and so let's test that now. So we have our 23, and indeed, 404 not found, invalid ID. So that's exactly what we just did, and it looks like it's working. Okay. Another solution that we could, of course, implement here as well would be to just do this test after we do the tour here. So we would get the ID, then we would try to find the tour, and if there was no tour, well, then we would say that the ID is invalid. So let's comment out this one, duplicate, just so that we actually keep both solutions here. And so we can say if there is no tour, okay, so basically the result here, if there is no tour found, well, that this variable here is basically undefined. And we can then test for that here like this. So if there's no tour, so if tour is basically undefined, well, then we send back this error message. So let's test that as well. And so indeed, it gives us the same result. Okay, and just like that, you learned how to specify parameters in a URL like this. Okay, then you learned how to read these parameters from the URL by using ret.params. Well, and then we used that ID, so that parameter, in order to find the tour with that exact ID. So that's what we did here in this line. Okay, so that was the goal for this video. And so let's now move on to the next one. After get and post, let's now learn how to handle patch requests to actually update data. And I'm pretty sure that at this point, you already have a good idea of how we're going to do that. So let's do that after post. So down here. And remember that we actually have two HTTP methods to update data. We have put and we have patch. And with put, we expect that our application receives the entire new updated object. And with patch, we only expect the properties that should actually be updated on the object. All right? So usually I like to use patch because I find it easier to simply update the properties that were updated. At least when we start using MongoDB and Mongoose, it will be much easier to just do it like that. All right? And it's also easier for the user to simply send the data that is changing instead of having to send the entire new object. Okay? So again, we are going to make our app work for patch and not for put. So we expect a patch request to come in on the URL, just like before, API/version1 tours. And now we actually also need the ID of the tour that should be updated, right? And so that is slash and then ID. Okay, so that's what we learned in the last lecture. So what do we want to do when there is a patch request? So when we want to update the data? Well, actually, I'm not really going to implement this operation here, because that's just a matter of writing some more JavaScript that is not really important. Because again, this is just a testing API using files. And in the real world, we're never going to use files for that anyway. Okay? So I'm really just implementing all of these verbs here so that you get a good idea of the different verbs that we use with HTTP, the kind of status codes that we send back. For example, here we send 201, while here we send it 200 and 400. And also, for example, here, when we had multiple tours, we sent the results. And when we created a new tour, we sent that data back immediately. So with this new tour that was created. And so that's the kind of stuff that I want you to learn for now in this section. So the basics of working with Express, of course, and also the correct way of sending back API responses. Okay? And so again, I'm not going to implement the updating of a tour here because that would be a lot of work. We would have to get the tour from the JSON file, then change that tour, and then save it again to the file. And that's a bit too much work here. And so let's simply go ahead and send back a standard response. So response dot status, and we will still use 200 here. So when we update an object or a resource, we send back 200 for OK, and then the usual JSON with the status of success, and then we send back the data, and in this case the updated tour. So we say tour, and then here in this position we would then send back the updated tour. Okay, right now I'm going to send back a string which says like updated tour here, something like this. So basically just a placeholder here. Okay, and we can also kind of implement this code here. So in order to only send this when the ID is actually valid. So let's get that from here. And so this way we can also actually use this ID here, right? So we're not gonna do this one because we don't have any tour, but we will use this one. So this will be rec.params.id, and I'm converting it to a number here as well, times 1. And if it is greater than the tour's length, well then, just like before, it is an invalid ID, and we send a 404 for not found. And so like this, we should now be ready to test it. Okay. So let's first of all save the request that we did in the previous lecture. So just get tour. And now I'm just going to go ahead and copy this one here. And let's specify the patch method. So this one is patch, and I will save it here right away as update tour. Okay, and you see that this one here gets this gray text. So they are very easy to distinguish here in this side column. So we actually also should specify some body here. So let's just go ahead and copy it from here. So remember, body, raw, and then JSON, just like this. And so let's say that all that I want to do is to change the tour number 3, let's say. So let's take a look at that one. So 1, 2, 3, and I want to change the duration to 15. Okay, saving it again. I'm going to save this one as well, because then it will actually save this text here in a body. And if I now close it and open it up again later, then all this text here is back, and that will make my life a lot easier then. Okay, but anyway, back to this one, we set the duration to 15. Now keep in mind that this will of course not change anything in the data because we did not implement that. Okay, so I'm sending the response now, and so here we see updated tour here, which is the place where in the real world we would then get the updated data back, right? Just to test it with a wrong ID, we get this fail and this invalid ID. Okay, so give it a save and close it up, and I'm going to close up this one as well. Okay, so almost done with the CRUD operations, so create, read, update, and delete. And as you can hear, the last one that is missing is delete, and so let's take care of that in the next video. Finally, let's now handle delete requests as well. And just like in the previous lecture, I will not actually implement the deleting of a resource in our route handler. Okay, so that is not necessary because again, we are only dealing with files, which is not a real world scenario. Okay, so I simply went ahead and copied the handler that we created in the last lecture. And so let's just do some quick changes here to handle the delete request as well. So the first thing is of course this method here, which is now not patch, but delete. Okay, then we still need to pass in an ID for the tour that we actually want to delete. And then let's also change our response. So when we have a delete request, the response is usually a 204. And 204 means no content. And so that's because, as a result, we usually don't send any data back. Instead, we just send null. Okay, so the status is still a success, but the data is null, simply to show that the resource that we deleted now no longer exists. So that is what null means. Okay, so pretty similar to patch. The difference here, in this case here, is that we changed the delete method, we changed the status code to no content, which is 204, and the data that we send back is null. Okay, and so even in the real world, that is exactly the response that we're going to send back. Okay, so now all we have to do is go ahead and test it out. And using, of course, delete. Let me also save it here as delete tour. And so let's pretend that we want to delete tour number 7. Again, that's not going to do anything. And so here we have our 204 no content. And actually Postman then indeed shows us here no content at all. So it doesn't even show us the JSON that we sent back. It simply gives us 204 no content. Okay, so let's just save it here. And so yeah, we have it here on the left side now as well. And you see that our collection here is steadily growing. So that's really cool. Now in the next video, we will actually make our code look a bit nicer. So organize it and follow some best practices to make our code a bit less messy. Let's now refactor our code a little bit. So basically reorganize some of our routes to make the code a lot better. So right now we have all these routes here. So the HTTP method plus the URL together with the route handler, which is this callback function, right? And we have these routes and route handlers kind of all over the place. So we have this and then this and all after the other, but it's kind of difficult to see what routes we actually have in our code. So all the routes should kind of be together, and then the handler functions also together, so separate from these routes here. Okay, and so what I'm going to do is to go ahead and basically export all of these handler functions into their own function. Okay, first of all, let's also get rid of this old code that we had here. And so yeah, let's take this, or actually not just this, so all of this. Let's take this and create a new function out of it. So I'm calling this one get all tours, and then I'm assigning it this function. Give it a save, and now here, instead of passing the callback function directly, well, I just do get all tours, and that's it. Okay, and so right now, if I'm gonna hit this route here, so this endpoint, it will then simply call this get all tours function. So the functionality didn't change at all, but I did slightly refactor my code. Okay, and you will see how nice this is going to be when all of the routes are together and all these route handlers are also together. So this one is get tour, because this is only to get one tour, right? And so here, get tour. So, and we're starting to see all of the different routes that we have in our project at one glance. So this is the next one, and it's going to be create tour. So const create tour equals all of this, and here then create tour. Next up we have, not like this, we have update tour. All right, and so this also actually makes our code look more declarative, right? So we can see very easily what happens here when we're actually reading the code. So when we read this line of code, we immediately see, oh, this will update the tour because we actually have the function name here. Okay, and now finally we have delete tour. Okay, delete tour. So this looks a lot nicer already, but it's still not perfect. We can do even better. Because let's say that we want to, for example, change the version or the resource name. We would then have to change it in all of these 5 places, and that is not ideal. And so instead of having all of this, we can do something better. So let me actually start it from scratch and write app.route. So that's a new one. And so here we specify the route that we want. So let's start actually with this one here. And then on there is where we specify what we want to happen on get. .get, well, we want get all tours. So what we have here is right now exactly the same as we have here. Okay, so let's comment out this part. So it's exactly the same. Now the thing is that here we can now actually chain the post method. And then we can say create tour, just like this. Okay, and so just like this, we have now actually created an even better way of writing a route. Because right now, this is not repeated for the get and the post. Okay, let's give it a save. It's nicely formatted and even easier to read than before. Okay, so the two route handlers that we use on this kind of route here, so without the ID, is only for get and for post. So for getting all tours and for creating a new tour. And now, as you can imagine, let's do the same for the other route. So basically this URL here. So we have this URL, and now we will have get, patch, and delete. So this one is get tour. This one is update tour. Oh, it's already there. And finally, I have delete tour. So delete tour. Give it a save. And we can now go ahead and, well, I'm not going to delete it so that we can keep the old code here as well. But this is going to work just the exact same way, but making the code a lot better and also easier to read, right? So again, just to recap, we separated our handler function of the route itself so that we can later actually even export these into another file. Okay, so that will then make the code even better. But for now, let's keep it at this. So with the handlers nicely separated from the routes, and then we specified all the actions for each of our two routes, which are simply tours and then tours / the ID parameter. So just to make sure it still works, let's use this one here and with a tour that actually exists. But you can see already it's not giving us an error, and so it actually still works. The same for get all tours, because that's another URL. And just to make sure it still works as well, indeed, it does. In the last couple of lectures, I hope you started getting the fundamentals of Express development. And so now is the perfect time to dive a bit deeper into how Express works, and for that, we need to talk about middleware and the request response cycle. So really, the essence of Express development is to understand and then use the request response cycle. And so I want to make that idea really clear in a visual way in this video. So to start the request response cycle, our Express app receives a request when someone hits our server, for which it will then create a request and response objects. That data will then be used and processed in order to generate and send back a meaningful response. Now, in order to process that data, in Express we use something called middleware, which can manipulate the request or the response object, or really execute any other code that we'd like. So middleware doesn't always have to be just about the request or the response object, but it usually is mostly about the request. And actually, we already used middleware before. We used express.json to get access to the request body on the request object. Remember that? Now, it's called middleware, remember, because it's a function that is executed between so in the middle of receiving the request and sending the response. And actually, we can say that in Express, everything is a middleware, even our route definitions. So again, even when we defined our routes, we can think of the route handler functions that we wrote as middleware functions. They are simply middleware functions that are only executed for certain routes. Okay? Now, some examples of middleware are express.json, which is also called body parser and that we already used before, or some logging functionality, or setting some specific HTTP headers. The possibilities are really endless with middleware. Alright, and now in more technical terms, we say that all the middleware together that we use in our app is called the middleware stack. And what's very important to keep in mind here is that the order of middleware in the stack is actually defined by the order they are defined in the code. So a middleware that appears first in the code is executed before one that appears later. And so the order of the code matters a lot in Express, okay? Now you can think of the whole process like this. Our request and response objects that were created in the beginning go through each middleware where they are processed or where just some other code is executed. Then at the end of each middleware function, a next function is called, which is a function that we have access to in each middleware function, just like the request and response objects. And we will of course see this in code in the next video. So when we call the next function, the next middleware in the stack will be executed with the exact same request and response objects. And that happens with all the middlewares until we reach the last one. And so just like this, the initial request and response objects go through each middleware step by step. And you can think of this whole process as kind of a pipeline where our data goes through, so just like it's being piped from request to final response. Alright? Now about that last middleware function, it's usually a route handler, just like we coded before. So in this handler, we do actually not call the next function to move to the next middleware. Instead, we finally send the response data back to the client. And like this, we then finish the so-called request-response cycle. Alright? So the request-response cycle is really everything that we talked about here together. It starts with the incoming request, then executing all the middleware in the middleware stack step by step, and finally sending the response to finish the cycle. So you see, it's really not complicated. It's actually just a linear process. But I wish someone would have showed me something like this when I was learning how to build Express apps. I mean, I could build them, but in the beginning I didn't really understand this entire request-response cycle like this. It was very confusing. So that's why I'm showing you this, because I believe it will be much easier for you in order to move on to the course now after understanding exactly how Express apps work. So after all the talk about middleware, let's now actually go ahead and create our own middleware functions. And again, remember that we actually already used middleware before. So let's take a look at that. And somewhere up here. And so you see that in order to use middleware, we used app.use. Okay, so the use method is the one that we use in order to, actually use middleware. So add middleware to our middleware stack. Okay, so this express.json here, calling this JSON method, basically returns a function. Okay, and so that function is then added to the middleware stack. And so similar to that, we can create our own middleware function. So let's do that now. And so of course, we still need to use app.use. Okay, and so now in here, all we have to do is to pass in our function that we want to add to the middleware stack. So remember from the last video that of course in each middleware function we have access to the request and the response. Okay, but also we have the next function. And so just like this, we add it as a third argument to this middleware function. Okay, and like this, Express then knows that we are actually defining a middleware here. All right. Now, just like before, actually, we could have called this argument here something else, like x or n, or it doesn't really matter. What matters is that it's the third argument to this function. So express basically passes the next function as the third argument into this middleware function, and we can then call it whatever we want. But again, next is really the convention in express, and so in order to avoid confusion, we always use this name. Okay, and the same for request and response. As I mentioned before, we could call them something else, but the convention is to call them like this. Anyway, let's just log something to the console here in this middleware function, just so that we have some code to actually run each time there is a new request. So let's say hello from the middleware. And add some emoji here, again, to make it pop a little bit. I really like that. Oh, what happens here? Oh, right. So that is the code that we want to execute here. And now, just as we talked in the last video, we actually need to call the next function, okay? And if we didn't call next here, well, then the request response cycle would really be stuck at this point. We wouldn't be able to move on, and we would never ever send back a response to the client. So I can't stress enough how important it is to never forget to use next in all of your middlewares. Okay? And it's as simple as that. All we have to do is to specify next, so this argument here, and then actually call that function like this. Okay, and with that, we are actually ready to test it out. And all we have to do is to send a simple request to our API. So here is the API. Let's close up this one here. And so it doesn't really matter, because this of course applies to every single request. So let's go back. And indeed, we have hello from the middleware logged to our console. Okay, so great. And I wanted to quickly touch on what I just said before, which is that this middleware here applies to each and every single request. Okay, and that's because we didn't specify any route. So remember that before I said that our route handlers here are actually kind of middleware themselves. They are simply middleware functions that only apply for a certain URL, so a certain route. Okay, but these more simple middleware functions that we define up here, well, they are going to apply to every single request, at least if the route handler comes before this middleware. So let me actually show you something, and I'm going to cut it from here and now actually put it here after this route handler. So what do you think is going to happen now when I make a call to this route? So let's see what happens. So this exact route, so the one that I just showed you, let me send a request to that. And now let's go back. And now we don't have hello from the middleware. So why is that? Well, simply because this middleware, so this route handler here, it comes before this middleware function that we have here. And this route handler, which in this case is getAllTours, actually ends the request response cycle. So let's take a look at that. So we have getAllTours. So where is that? Yeah, so here is the function. And by sending a result with res.json, we actually end the request response cycle. And so the next middleware in the stack, which in this case is this one, so our custom one, will then not be called. Again, because the cycle has already finished, okay? So make sure to understand that this order really matters a lot in Express, okay? It's fundamental to understand that this is how Express apps work, okay? So in order to kind of test that, let's try to see what happens when we do a request to this route. So to get tour, update tour, or delete tour. So let's do this one. Send a request here, and let's go back. And now we have hello from the middleware. And so that is actually what we expected, right? So that is because, of course, this middleware here now is before the route handler. And so it is, of course, part of the middleware stack that gets executed before the request response cycle ends. All right? Makes sense? So let's take that back. And so usually we define this kind of global middleware here before all our route handlers. All right? So this is one very simple middleware function that we just defined to run some code, but let's actually do another one. And of course we can have as many middleware functions as we like, and this time we actually want to manipulate the request object. So the signature here is always the same, always request, response, and next. And now let's actually manipulate the request. all we want to do in this case is to add the current time to the request. So we can simply define a property on the request object called request time, and then set it to a new date, which basically translates to right now. And then we can use a very handy date function, which is called to ISO string, which will then convert it into a nice readable string for us. So let's pretend we have some route handler that really needs the information about when exactly the request happens. And so the very simple solution is to simply add something like this to a request using middleware. All right? Now, don't forget, of course, to call the next middleware in the stack. Okay? So right now we have request time on our request. So we can now use some route handler here, for example, the one for getting all the tours, to simply log that for us to the console. So console.log, and it's actually request time. Okay? Or we could even send this in the response as well. Let me just test that. And let's just call this one requested at and rec.request time. That's the one. And so yeah, let's go ahead and figure this one out. So our middleware is correct, right? Yeah, so we call next when we're done. And so let's test this now. Remember, it's on get all tours. And when we go back now, or when we go up, well, it should actually be here. So what is wrong here? So you see that down here, we actually just logged a function. And yeah, of course, we didn't actually call the toISO string. So it's a method. We have to call it. So give it a save. Try it again. And now we have requested at and then today's date. So perfect. That came from our middleware. So simply because we added that property to our request. Great. So I hope that with that, you made a great step forward in order to really understand how Node apps work, how middleware works, how the entire request response cycle works, because that really is going to make all the difference when you're writing your own applications. Let's now use a third-party middleware function from NPM called Morgan in order to make our development life a bit easier. So as I mentioned, we're going to use a middleware called Morgan, which is a very popular logging middleware. So a middleware that's going to allow us to see request data right in the console. Okay, so let me go ahead and install it, and you will then see how that works. Okay, so I don't want to now finish this process here, so I'm going to create a new terminal here in VS Code. And so for that, I hit this plus button here. And so now we get a new terminal. And I don't want to update, so no. And now npm install Morgan. Okay. Now, as I mentioned, this logging middleware is going to make our development life a bit easier. But it still is code that we will actually include in our application. And so that's why it's not a development dependency, but just a simple regular dependency. Okay, and so that's why I didn't specify safe def here, because again, it's not a def dependency really. Okay, so we have it in our package.json here now, Morgan. And so let's go ahead and require it in our code. So again, right at the top here, const Morgan equals require Morgan. And you see again, this kind of convention that the require is going to expose is usually the same name as the package name itself. So we have our middlewares here. So let's add it right after these, or actually right as the first one. Okay, and our code is growing a little bit. So let's actually go ahead and add some comments here. So first, middlewares. Then down here, we start having our route handlers. Right. Then here, let's just say we have our routes. And then finally down here, we start the server. Okay, so just to make our code a bit more readable and easier to scan. So we have this first middleware, but again, let's use ours before that. So of course, app.use, and now in here we call Morgan. Okay, and into this function, we can pass an argument which will kind of specify how we want the logging to look like. So we can use some predefined strings for that, and the one that I'm going to use is called def. And actually you can see here the different options. So VS Code is really smart and can give me the options that we can pass into this function. Okay, so as I mentioned, I'm going to use the one called def. Okay, and so that's actually it. So we required it, and then here we used it. So very simple stuff. But I think it's important to actually try to understand how this works. So calling this Morgan function will return a function similar to this one here, right? So that makes sense because, well, this is how a middleware function has to look like. And so let me actually prove that to you by looking at the source code for this package. And that's another very nice exercise from which we can actually learn quite a bit. So let's search for Morgan on GitHub. So usually all these packages are always on GitHub. And so that's where we can then look at their open source code. Okay, and Morgan is actually a very simple package. And so all we have to do is to go to this index.js file. So usually that is the entry point. And in this case, it's kind of the only file that there is. Okay, now I'm not going to go over all of this code, but I want to highlight that the main export from this file here is Morgan. So a function called Morgan. So let's look for that. And actually here it is. Okay, and so when we require the package in our code, what will get returned is this Morgan function, right? Again, because they use module.export, and that is the default export, just like we learned in the requiring modules lecture 1 section or 2 sections ago, right? So again, this Morgan function here will be this Morgan function here in this code, okay? So let's see what this function does. And I don't care about any of this implementation here. What I really want to show you is that this function actually returns another function, which is the logger. And you see that this function, just as our own middleware functions, has this very typical signature of request, response, and next. Okay? So this function is just like our own middleware functions. And so you see that actually in the end, when it's ready, it also calls next. So just like we do. So it's just a very regular middleware function, just like the ones that we write. Okay? So let's go back here, and let's now actually see the result here in our terminal. So let's go back to that first one. So this is how we switch between the different terminals that we have open in VS Code. Give us some more space here. Actually clear this out because you might not be able to see the bottom of the screen so well. And so yeah, let's now go ahead and simply create some request. All right, go back, and here we go. So here we have the information about the request that we just did. So we get the HTTP method, we get the URL, we get the status code, the time it took to send back the response, and also the size of the response in bytes. So remember, we could have used another option here. For example, tiny was another one. So that would then probably look a bit different. And it actually looks kind of similar here. It simply doesn't do this coloring of the status code. And also it has a slightly different order here. Okay. And if we did something, if we caused an error, for example, a 404, let's test that out by using an invalid ID here. So that will then get another color here, right? Can see that? Let's do that again, just in case you didn't see it. And so, yeah, gives us a different color. And so, yeah, that can be quite useful for development. We could actually even save this log to a file, but that's a bit too much for this small example. So this is more than enough, and you will see throughout the course that it's kind of useful to actually have it here. Okay, so this is how we use third-party middleware from NPM, and there is a lot of middleware on there. And let me actually show that to you. So on the Express side itself, so expressjs.com, and we actually never visited this website, so it's actually quite nice. So you have this getting started with a couple of articles explaining the basics of Express, and then you have a nice API reference, in our case 4.x. And so here you have all of the methods that are on the request. So methods on properties, of course. So all of this stuff that we have, for example, request.body that we already used, or here on the response, you have, for example, response.json or response.send. And there's a bunch of other methods, and we will use many of them later on. And then here you have these resources, and the one that I want to show you is middleware. And so this is a bunch of middleware that you can use and that Express recommends. Okay, and again, we will use some of them a bit later. And actually, Express recommends these because many of these used to be built in Express 3, so in the previous version, but were then taken out of Express. For example, body parser is one of them, but actually in version 4. I believe 14 or 16, it was added back. And so that's why we were able to do, let's see, where is it? Yeah, that's why we were able to use express.json in order to parse the data from the body. Before that, we actually would have to use the body parser from npm and use that one to parse the data from the body. But again, they just recently added it back to reduce the confusion a bit for beginners like yourself. Okay, so play around a little bit with this reference. Take a look at some of the stuff maybe that we already did, if you feel like it. Or if not, you can always just move on right to the next video. Welcome back. In this video, let's start to implement some routes for the user's resource. So our API will have a couple of different resources. The first one that we already talked about and started to implement is the Natours resource. But another one will be the user's resource, so that, for example, we can create user accounts and have different user roles and all that good stuff that comes with users, right? Now, of course, for now, this user's resource will be very similar to the Natours resource. But I still want to start implementing this resource at this point because we need to move forward in the project, and also because I need it in order to prepare for what I'm going to teach you next. Okay, so let's go ahead and move down here to our routes. And so I will do, again, something very similar to what we already have here. So app.route, and the route is going to be /API/version1 and then users, okay? And then we will respond to the GET requests using a function that I'm going to create next called GET all users. So you see that the structure that I'm going to follow is very similar to the one with Natours. So when we do GET or POST on a route without the ID, so just like this or just like this, it means that we either want to get all the users, so basically all the objects that are part of one resource, and if we use POST, then we want to create a new resource on a server, okay? So that pattern is always going to be the same. So create user for now. And so now it's giving me an error because all these functions are not defined, but don't worry about that. So API, actually slash, so we always need to start with the slash users, and then just like before, we have the user's ID as a parameter in the route. Okay, then if we do a GET request specifying that ID, it means that we want to get one user. So I'm just calling it get user, okay? And there are different kind of standards here. So you could call this one here get one user and this one get all users, but I prefer to just do it like this, all right? So we also want to respond to the patch request. So update user, and then also delete. And this one is going to be called delete user. Give it a save. And so it nicely formats our code here. And so let's go ahead and quickly create these 5 functions. And we're going to do that all right away because we will actually not do anything for the users at this point. Okay, again, I just wanted to have this implemented in order to show you something next. Okay, so I'm going to go ahead, copy this one here. And yeah, so add it here right after the last route handler from the tours. So const get all users. And what I will do here is to simply send back a message that this route is not yet implemented. So response, the status that I'm going to specify is 500, which means internal server error. And so yeah, for now, that's just kind of a placeholder. So we still send back a JSON object with a status, which in this case, when there is a 500 error code, we say that it's an error. Okay, so what was that weird autocompletion? We simply only want error. And then message, this route is not yet defined. All right, give this a save. And now I'm going to go ahead and copy this a couple of times and simply do the same for all the other ones. Okay, so get all users, then get user, then I want create user, I want to update user, and delete, oh, where is that? It's nowhere here. Delete user. Okay, so now there's no more error, and let's get rid of this piece of code. And so if we now create a request for this, let's see what happens. And close this one, copy this one, and yeah, of course. So I needed to change this to users, obviously. And so now we have our 500 internal server error here, and then this route is not yet defined. Let's still go ahead and save this request into a new collection. Actually, we want it in the same collection, just another folder. So let's create a folder later. So get all users. Save it here, and now we can go ahead and create a folder, and not like this, but this. So add folder, and so let's add one folder for each of the resource. So we have tour, and we have users. So it's gonna be called just like the resource. For some reason I cannot select all of them. That's no problem. All right. So now we have them nicely organized here in our collection, and that's a lot nicer. All right, so that is how we define the code for our second resource. Now right now this file is kind of a mess, so we have all of this mixed up together in the same file, all these routes, all these handlers here, which we can also call controllers, by the way. Okay, and so we have all these different pieces in the same file. And eventually, we will want to fix that. So in the next video, we're going to take the first step in order to be able to actually separate all these different pieces into different files. In this lecture, things will start to get a bit more advanced. And that is because we will now create multiple routers and use a process called mounting. So let's see how all that works. Now, before doing any of that, let's keep in mind that the ultimate goal will be to separate all the code that we have in this file into multiple files. So what I want is to have one file that only contains all of these routes. Then I want to have another file which has the routes for the users. I will also want to have a file which contains the handlers only for the users, and then also one file that will contain all the handlers for the tours, okay? And so that's actually what we're going to do in the next lecture. But in order to be able to do that, we actually need to now create one separate router for each of our resources. So let's go back to our routes here. And so right now we can say that all our routes, so these 4 routes here, we can say that they are all kind of on the same router. Okay, and that router is this app object. But if we want to separate these routes into different files, so again, one file for these 2 routes and one file for these 2 routes, then the best thing to do is to create one router for each of the resources, okay? And so this is how we're going to do. It's actually not that complicated, but you will have to wrap your head around a couple of concepts, okay? So let's start by saying const tour router is equal to express dot router. Okay, so just like this, we create a new router and save it into this variable. All right, and so now let's use that router for these 2 routes. So here we use it instead of app. All right, so now we have 2 router and then route, and then of course the get and the post routes on that router. Now, how do we actually connect this new router with our application? Well, we will use it as middleware. All right, and so that is because this new modular tour router here is actually a real middleware. All right, and so we can say app.use and then the route, but let's keep that for later. So we can use the tour router on our application. And where do we want to use the tour router? Well, we want to use it on /API version 1 /tours. Okay, so again, this tour router here is a real middleware. And we want to use that middleware for this specific route. Okay, and so we use app.use, specify the middleware function, which is this router, and then we specify the route, so the URL, for which we actually want to use that middleware. Okay, and so just like this, we created basically a sub application. Okay, now there's just one thing that we really need to change here, which is these routes in here. Okay, so let me change this here and then explain why it has to be this way. So here we only want the root, and here we only want the ID. Okay, now why is that? Well, it's because this tour router middleware only runs on this route here anyway. Okay, and so once we are in the router, then we already are at this route, so at our tour route. And so this first route that we had here before, we only want to run it at API/version1/tours. And so that is what this route here now means. Okay, so it's basically the root of this URL. Okay, so of this small mini application. All right, so actually when we create a router system like this, we actually say that we kind of create a small sub app for each of these resources. Okay, so this is the root of our mini application, which is again at /tours. Okay, and then the second route is at /ID, right? And that's because before it was at tours/ID. So it was all of this, so like this. But now this URL here is already in our kind of parent route up here, right? So let's say that we have an incoming request now for /API version1/tours version ID. So the request goes into the middleware stack, and when it hits this line of code here, it will match this URL here, right? So it will match this route, and therefore our tour router middleware function will run. So our tour router is this sub application that we created, which in turn has its own routes. Okay, and if the request was for /ID, well, then it will inside our mini app hit this route here, right? And finally, of course, it will run one of these handlers here, depending on the method that was used. So I hope that made sense. And so let's now actually go ahead and do the same for our users. All right. So I will go ahead and create another router here called the user router. And then just like before, it's express dot router. Not like that. Yeah. Okay, so user router. And then we need to do the same process as here. And by the way, this is called mounting the router. Okay, so mounting a new router on a route, basically. Okay, so we have now users and here user. And actually, mounting the routers has to come after all of these definitions, or at least after we declare the variable, right? So we cannot use the routers before we actually declare them. Okay, now all we need to do is to go ahead and also change the routes in here. And so just like before, if there is now a request for /API/version1/users/ID, the request will enter the middleware stack, and when it hits this middleware here, it will run the user router because this route here is matched. Okay, and so then it enters the user router, and again, just like before, this here is the root basically in our sub application, and then this here is the entire URL/ID. Okay, does that make sense? So before moving on, let's actually test if this still works. So let's get all the tours here, and indeed it does. So everything still works. Do the same with the users, and also that still works. So we did all these changes and the code still works, meaning that our two new routers are correctly mounted. All right, and with that, we are ready to actually separate our different routers now into different files. And that we will do right in the next lecture. Let's now completely refactor our application that we have so far and create a lot of new files and a whole new file structure. So remember from the last video that we wanted to separate our routers into different files. And so that's going to be the first step that we will do here. So I'm going to create a new folder called routes now. And then in there, I will have one file for tour routes.js and then user routes.js as well. Okay, and so this is going to be the first time that we will really work with different modules, okay, and actually use them in a very meaningful way. So let's start with the tour router. Copy it here, then take this tour router here and put it here. And so next we need actually express here because we're using that variable. And so we need to import the express module. So express require express. Okay, it's kind of a convention to simply call this router and not tour router. So router, and now we will export the router and then import it into our main application. Okay, so remember how we do it when we only have one thing to export? Well, we use module.export and then put the router on there. Give it a save, and of course we still get some errors, but that's because the tour router is not defined in our main application file. Okay, also what's not defined in this file is all of these functions here. Okay, so let's very quickly get them and put them in the router file, at least for now. We will later create a new file for that as well. So it starts here. And careful not copying everything. Yeah, so just like this. And actually I'm going to put them before the routes. Give it a save. And so that should work now. And now do the same for the user. So get the router. And don't worry about all these errors that we're getting. Again, that's just because we are missing some variables in some places. So again, we need express here. Then we call this here just router. And then we export it. Okay, and now I'm also getting the handlers. Okay, so we can get rid of these route handlers now. Okay, and actually this one here is missing in our tour routes. So this piece of code where we actually read the tours from the JSON file. So put that right at the top here. And now finally we actually need to import the tour router and the user router so that these routes here continue to work. Okay, but that should be fairly easy. So let's do that. So the tour router is at require routes slash tour routes. Okay, and we don't need the JS. And then the same for the user router. So tour routes, and actually it is here, the user routes. Now you might be wondering why I actually call the variables the user route, but then the file is user routes. And well, that's because this folder here is called routes. And so in there we have the tour routes and the user routes. Okay, but what we actually export from that file is simply the router, all right? But I believe it makes more sense to actually call this folder here routes. Okay, and so that's why we have this small difference between routes and router. Now we still get some error here, and so fs is not defined. So let's take that, and actually we don't need it here. So let's put it in the tour routes. Right here. We get another error, and this time because this folder here is now not defined, because our dir name is now the routes. So we need to get out of that. So go up one folder, and then in there go into dev data, data, and tour simple. Now don't worry about getting all these errors. That's kind of normal when we are doing all this refactoring, because we're changing stuff all over the place. So it's normal that stuff breaks. Anyway, it's now back to working, and so we are now in a place where we can retest our routes here. And indeed, it works. The same for the users, let's suppose. And so everything is correct. So we have our routers now each in one different file, and we can say that each of them is one small sub-application. So one tour application and one user application. And we then put everything together in our global app file by importing these routers and then mounting the routers on the two different routes that we have currently implemented. Okay? So again, this is where we mount our routers. And I know that this concept can be a bit difficult to grasp, but don't worry about that. The longer you keep working on this project and the more code you keep writing, the clearer everything will automatically become. For now, the most important thing to keep in mind is that we created these different routers for each of the resources to have a nice separation of concern between these resources. So basically creating one small application for each of them and then putting everything together in one main app file, which is of course this one. So this app.js file that we have here is usually mainly used for middleware declarations. So we have all the middleware that we want to apply to all the routes. So in this case, we have these four middlewares here. So 1, 2, 3, 4. These middlewares we want to apply for all of the routes. And then for this route, we want to apply the tour router middleware. And for this route, we want to apply the user router middleware. Okay, so again, these two routers are actually middleware, which is why we can use app.use in order to mount them. Okay, and with that being said, let's take it one step further and actually remove these route handlers from the routes file. Okay, and so let's again create a new folder here, and this one will be called controllers. Okay, so I've been calling them route handlers, and so it would make sense to create a handlers folder. But later in this course, we will start using a software architecture called the model view controller. And in that architecture, these handler functions here are actually called controllers. And so that's why I'm going to call the folder and also the files in there controllers. So let's now create the tour controller.js and the user controller.js. Okay, and this will make a bit more sense once we reach the part of the course where we actually talk about the MVC or model view controller pattern. All right, so let's now take this code and put these handlers into the controller folder or file actually. So all of this code, it's the tour controller. Yeah, that's the one. Also, we need this fs module here, obviously at the top. Here we go. Now we want to actually export all of these functions from this module. So how do we do that? Well, in this case, we do not only have one export, so we're not going to use module.export, but instead we will put all of these functions on the exports object. Okay, and so let me select all of these consts so that I can actually replace them all at the same time. So exports dot delete tour and dot update tour, create tour, get tour, and get all tours. Okay, so that exports everything from this file. And so now let's go into the tour routes and simply import them. So const tour controller equals require. Okay, now we're in the routes folder here, right? So we need to move up one level and then go into controllers and into the tour controller.js. Okay, this is not correct. And all right. Now remember that when we export data from a file using the exports object, so just like we did here, when we then import everything into one object, then all of the data that was on exports is now going to be on tour controller. And so we will have tour controller.getAllTours.createTours.getTour, and really all of these. Okay, so this object here will be the equivalent of the exports that we have here. Remember that? And so it's really simple. All I have to do now is to create tour controller dot, and that's it. Now I could have also used the structuring, which I also showed you before. So just to demonstrate, I could have used it like this and then specified the exact same names that we have here. So get all tours, and then create tour and all of these. And then I could have used them directly here without having to write tour controller and dot. Okay, but I actually like it like this, and I see no problem of having it like this. So it makes it nicely visible that all of these functions here actually come from this tour controller module. Okay, so I saved it now, and so it should keep working. So let's test that, and yeah, it does. So that's working now. Let's actually close it up, and now the same. Where is it? Here. Now the same, of course, with these functions. Put them here, and then export all these guys. So exports dot. Yeah, so that's correct. Now here we just import that module. And the same as before, we need to move up one level. We go into controllers and user controller. And now finally just add it here. Give it a save and test it for this guy as well. And indeed, it works. So everything we did here was correct. So we're starting to have a bunch of files now, and so it's important to really get familiar where exactly all the different pieces of the application are located. Okay, so just to recap, the flow goes like this. We start receiving the request in the app.js file, right? It will then, depending on the route, enter one of the routers. So let's say the tour router, and then depending again on that route and of the request, it will then execute one of these controllers here. And so these are in the tour controller files. And that's where then finally the response gets sent and finishing the request response cycle. Okay, so we have now 3 files instead of having everything just in one file. All right, but that's still not the end of the story because I'm adding one more step here. So what I'm going to do is to create a server.js file as well. So server.js. And why am I doing that? Well, simply because it's a good practice to have everything that is related to Express in one file and then everything that is related to the server in another main file. So starting now, server.js will actually be our starting file where everything starts, and it's there where we listen to our server. So let's actually go ahead and copy or cut this part from here and move it into the server. Now, of course, this module here doesn't know about app, and so we need to import it. And to import it, we need to first export it. So we use module that exports, and we export our application from this file. Okay, and so now we have everything that is basically the application configuration in one standalone file. Okay, so back in the server, let's now import that. Require, and since it's our own module, we need to use this / to say that we're in the current folder, and here it's simply app. So simple as that. And later on we will actually have other stuff in this file that is not related to Express, but still related to our application. So stuff like database configurations, or some error handling stuff, or environment variables, all of that stuff will live in this server.js, which is kind of our entry point. Okay, so let's now finish the process that we have here, because now we do no longer run nodemon app.js, but instead we need to run server.js. Okay, and actually since we're doing that, let me create an npm script for that. Closing that guy very quick. And so let me add here npm start nodemon server.js, because this way I no longer have to really know which is the file that I actually want to run. So all I have to write is npm start, and there's no doubt that it's going to work. Otherwise, I might have to think, is it app.js or server.js or what? What do I have to start here? But like this, I don't have to think. All I have to do is npm start, and it's gonna start. Okay, so just like this, and here we are back running our application. Close that guy. And by the way, this works even without having nodemon installed as our dev dependency, because I have nodemon installed globally. So we did that in the first section, and hopefully you did it there as well. If not, then go ahead and in another tab do npm install nodemon. So if for some reason you skip that section, you type npm install nodemon, and then you can either install it globally, like this, or you can install it as a dev dependency, like this. All right? So just make sure that you have nodemon installed, no matter if it's globally or as a dev dependency, okay, in order to make this work. So, final check, just to make sure, and on this one, and yeah, Indeed, we have our app correctly refactored. So, these were a lot of changes in one video alone, so after you finish this one, please go ahead and analyze everything that we did and really try to trace the path that a request will do inside of our app from start to finish. This way you will really get a feeling of how everything here works. And I see you after doing that in the next video. In this video, let's create a special type of middleware called param middleware. So param middleware is middleware that only runs for certain parameters. So basically, when we have a certain parameter in our URL. Now in our example here, the only parameter that we might have in our route URL is the ID, right? And so we can now write middleware that only runs when this ID is present in a URL. Okay, so let me show you how to do it. It is quite simple actually. So it's on our router and then the param method. Okay, and so here we specify first the parameter that we actually want to search for. So basically the parameter for which this middleware is going to run, and it's called ID. And then of course our actual middleware function. Okay. And as usual, we have access to the request and to the response object, and then, since it's a middleware function, also to the next function, right? Now, in a param middleware function, we actually get access to a fourth argument, and that one is the value of the parameter in question. Okay, so we usually call that one val, which stands for value. Okay, and so now we can go ahead and simply log it to the console just to take a look if this actually works. So let's say tour ID is, and then ID, right? Next up, we also have to call next, right? Because otherwise the request response cycle will get stuck in this middleware function and it's not going to be able to move on to the next middleware in the stack, right? Which are going to be these routes down here. All right. So let's give it a save and check it out now. And we want it not for get all users, but for get one tour, right? Now let me show you first what happens if we do not have any ID. Okay, and so now we don't see any log down in our console. But if I now send the same request on this route where we have the ID, let's see what happens then. Oh, it tells me that ID is not defined. And indeed, it's not ID, so that was a stupid mistake. So it is val for value, right? So remember how I said that this value parameter is the one that will actually hold the value of the ID parameter. And so of course, that's the one that we need to then use here in order to get access to that ID. So let's try that again. And now indeed, we have tour ID is 2, right? So that log came right from this function here. Now, what I also want to show you is that this middleware function is not going to run for any of the user routes. Okay, so let's say we call a users with a specific ID. So let's go ahead and copy this one here, and create a new request with an ID. And let me actually save it also. So get user and save to user. And when I send it here, we of course get our standard response of this route is not defined. But you also see that we have no log like we had before. And so that is of course because this middleware function is only specified in our tour router. So in this kind of local mini application. So again, that is the analogy that I like to make. So basically that each router is kind of a mini sub application, a one for each resource. Okay, and so since this middleware is only specified on this router, well then of course it is only part of the middleware stack if we are actually inside of this sub application. Make sense? So let's suppose we have an incoming request on tours/ID. So that request will then go through all these middlewares. So first this middleware, then this one, then this middleware, then this one. So all of these are part of the middleware stack, and then it will finally hit this middleware, and since this is actually the route, it will then get into the tour router middleware. Okay, and so from there, it then goes right into this middleware, and so then this code will be run, right? And again, that's only because it has an ID in the route. If not, well, then this would simply be ignored, and it would move on right to the next middleware in the stack. So these down here, right? Cool. So that is how param middleware works, but for now it is not really that useful, right? But we can actually use it for a very practical use case here. So let's go to our handler functions here, and you see that in all of the handler functions that actually use the ID, we check if the ID is valid, right? So we do it here in getTour, and we also do it in updateTour, so here, and in deleteTour. So all these three functions have this very similar code where they check if the ID is valid, and if not, they send back this invalid ID response. So we have all these code in the same place, and as you already know, it is not a good practice to repeat code. And so what we can do here is to use the concept of param middleware and perform this check here in an outside middleware that is going to run before the request even hits these handler functions. So let's go ahead and copy, or actually cut, the code from here and create a new middleware function called checkID. And of course, I also need to export that. So checkID, and we have access, request, response, next, and again, keep in mind that it is a param middleware, and so the fourth argument will be the value of the parameter. Okay, paste it here, and then don't forget to call next at the end of the middleware. All right, and what's also very important is that we have this return statement here. Okay, because if we didn't have this return here, well, then Express would send this response back, but it would still continue running the code in this function. And so after sending the response, it would then still hit this next function, and it would move on to the next middleware and would then send another response to the client. But that is really not allowed. So remember that we actually run into this error before, where it told us that we were not allowed to send headers after the response had already been sent. And so that's the kind of error that we would run into if we didn't have this return statement. Okay? So again, this makes sure that after sending this response, the function will return, so that it will finish and it will never call this next. Okay, so never forget that. But of course, we're going to do this multiple times throughout the rest of the course, and so you will get used to this kind of pattern. Okay, so let's go ahead and remove this repeated code from all of these other functions. So yeah, here we have it again. And yeah, well, I also want this code here just to make sure that the function is actually running. And okay, so now we can get rid of this here and replace it with our newly created controller function. So tour controller check ID. So let's check that out now. And well, again, just to make sure that it doesn't run where we do not have an ID. So we have no log here, so everything is still working on that side. And now get tour with a regular ID, so a valid ID. And so let's see. Well, we get the tour ID is log, and so that means that it did actually run or check ID middleware, right? And if we now try an invalid ID, well, then we get our invalid ID message, the 404 error code, and of course our to ID. Let's do the same with the patch. We already have an invalid ID here, and so it also runs on this one. So perfect, right? So we no longer have the check ID code in the update handler that we just invoked, basically, but still our ID is checked because we have that middleware. So this here, we have that middleware in the stack before it actually hits the update tour controller. So this middleware is now part of our pipeline as you can imagine it. Now you might argue that we might simply create a simple function which could also check for the ID and then call that function inside of each of these tour function and then call it inside of each of these relevant tour controllers. But that would really go against the philosophy of Express, where we should always work with the middleware stack, so with this pipeline, as much as we can. Okay? And so these functions here, they do not have to worry at all about validation. Each of these functions has only one purpose, which is to do what they say. So this one just gets the tour, this one just creates a tour, this one just updates, and this one just deletes. It doesn't check, it doesn't have to worry about any of that. Okay, and if we would now add another controller here also depending on the ID, well, then that would automatically also check if the ID is invalid without us having to do any additional steps. Okay, so this automatically will check for the ID, and so that's really handy, and also how Express apps should work. Great, so we have another tool in our Express toolbox that we can now use in order to write our Express applications. So in this lecture, you're going to learn how to chain multiple middleware functions for the same route. So up until this point, whenever we wanted to define a middleware, we only ever passed one middleware function. So for example here, for handling this post request, well, we only passed in this middleware function, which is our create tour handler. Okay, and so that's the only function that is going to be called whenever we get a post request, right? But let's now say that we want to actually run multiple middleware functions. Now, you might ask, why would we want to do that? Well, we might, for example, run a middleware before create tour here to actually check the data that is coming in the body, right? So a bit similar to what we had before. So we did this check ID middleware before in order to check if the ID is actually valid, and doing so outside of the actual route handlers so that they are only concerned with getting, updating, or deleting a tour, right? And so here in this specific example with post, we might want to do the same thing. So as I said, we might want to check if request.body actually contains the data that we want for the tour. Okay? And so let's do that. And actually, I want you to first do it on your own. So this is kind of a challenge that I want you to complete in order to use the concepts that we've talked about so many times at this point and create your own middleware function. So let me just write it here as a comment. So I want you to create a check body middleware function. And in there, I want you to check if the body contains the name property, so the tour name, and the price property. All right? And if not, I want you to send back a 400 status code. If not, send back 400, which stands for bad request. So basically an invalid request from the client, which is in this case trying to create a new tour without a name and without a price property. Okay, and that's actually it. And actually not, so I also want you to add it to the post handler stack, basically. Okay, so I want you to add it in here, and I will actually tell you how to do that because we didn't do it at this point. So it's very easy. So let's say our function is called middleware, and so what you have to do is to simply add that function here before the create tour handler that will ultimately create the tour. Okay, so this way, when we have a post request for this route, it will then run this middleware first and only then the create tour. Okay, so that's how we chain two different middlewares. But now I want you to go ahead and create this middleware actually called check body. So pause the video now and please try to do it on your own. Okay, so I hope you were successful doing that you tested it and that everything works. So now let me go ahead and implement it in my way. So we have this error here, but don't worry about it. it's because of this middleware that's not defined. And so let me do it here right after the check ID middleware. So exports dot check body. We have the request, response, and next. And so it's actually quite simple. So if there is no request dot body dot name, and I think that's the name, but let's quickly go ahead and check that. So it is here in tour simple. And yeah, and indeed it's called name, and the other one is price. So if there is no request body name or no request body dot price, well, in this case, we will, just as before, return from this function and send back a response. So the status here is, remember, 400, and then some JSON where the status is fail. So that's always when we have a 400 code, and then the message missing name or price. Okay, so price and name need to be there at the same time. So if either the price is not there or the name is not there, then we already sent this error message. Okay, but if everything is correct, well then we want to move on to the next middleware. And so that's what we say here. And the next middleware will of course be create tour. So this one. So let's go ahead and then add it here. So tour controller, check body. All right, so now the error is gone and we should be able to test it now. So let's close the ones we're not interested in and create a new tour. So right now we have our body with the name, duration, and difficulty, but there is no price. So we should now get our error, right? So let's test that, send, and indeed we have missing name or price with our 400 bad request. Okay, and so let's analyze what happened here again. So our request hit this route here, and it was a post request, and so it then ran this middleware function, and from this function we then send out this response saying that, well, the name or the price is missing. Okay, but if we now add the price, so it doesn't really matter which price, send it, well, then everything works just fine, and we get it to 01, created. So what happened this time? Well, it checked for the body, and this condition was not true, and so it called the next middleware in the stack, which is create tour. So it created a tour and sent back the result, and like this finished the request response cycle, right? So I hope that was a nice small challenge, and we will be using this kind of logic here all the time, where we chain multiple kind of handlers here for the same route. So for example, here we could check if a certain user is logged in, or if he has the privileges, so the access rights to even write a new tour, or really all kinds of stuff that we want to happen before the tour is actually created. Okay, and once again we do that because we want to take all the logic that is not really concerned with creating the new resource outside of that handler, so that that handler is only concerned really with the work that it is supposed to do. Let's now learn how to serve static files with Express. Now, what do I actually mean with static files? Well, it's the files that are sitting in our file system that we currently cannot access using our routes. So for example, we have this overview.html file here in our public folder, but right now there's no way that we can access this using a browser, right? And the same for these image files that we have here, or the CSS or the JavaScript files. So let me show that to you. And let me actually use the browser this time. For now, I'm copying this URL here just to show you that it's going to work obviously also in the browser. Okay, so this is our unformatted result here from the same route. But let's say that we actually want to access that HTML file that I was just talking about. So we can, of course, not just write public and then, for example, overview.html, right? There's no way we can access this right now, and that's simply because we didn't define any route for this URL, right? We do not have any handler that is associated to this route, okay? And so if we actually want to access something from our file system, we need to use a built-in Express middleware, okay? So let me now show you how we can do that. For example, after this one, okay? Now, in this section, we're actually just talking about an API, so we don't actually need to serve static files like images or HTML, so what I just showed you. But since this section is an introduction to Express in general, I also wanted to quickly show this content to you anyway. Okay, so as I was saying, all we have to do is to use a simple built-in middleware that goes like this. So express.static, because we want to serve static files, and so this is an obvious name for that. And so in here, we pass the directory from which we want to serve static files. And in this case, I'm going to use the public directory. So this folder here where we have these HTML files, okay? And actually, let's use a template string here so that I can go ahead and use the dir name variable, then slash, and public. Give it a save and go back to the browser. Then we will be able to open this overview.html. Now it's not going to work in this URL here. It actually has to be like this. So without the public, just /overview.html. So let's see, and that actually works. Okay, now why is that? Why don't we need the public folder here in the URL? Well, simply because when we open up a URL that it can't find in any of our routes, it will then look in that public folder that we defined, and it kind of sets that folder to the root. Okay, so let's pretend that the root is now our public folder, so this here, and then the overview is in there, and so that's why we have then access to it. So in there we also have images. For example, let's say we want to open image and then this pin here, and we can do that. So image pin PNG, and so here we go. Here is the image. Now what we can't do is this, because this is not a file. This looks like a regular route, and so Express actually tries to find a route handler for this one, which it can't because we didn't define anything. All right, so it really just works for static files, in which case it will again not go into any route, but simply serve that file that we specified from the public folder, or the folder that we specified here in this middleware. Okay, now take a look at the console here and see all the requests that were actually done when we open up that page. Let's now clear this here just so we see all the requests that actually just come from that overview page. So let's write again overview.html here, and these images here are broken, and that's because this HTML is not supposed to be served like this. All right, I'm just using it now here so that we get some visual feedback. I'm not interested at all in the content here. Okay, now just take a look at all the requests that were done for all of the assets. So as I said right in the beginning, for each piece that is part of the website, our server actually gets a separate request. And you see here that most of them get this 404. So that's why the links are then broken on the web page. Well, simply because Express cannot find them in this folder. But again, that's not the point here. What I just wanted to show you is how we can serve static files from a folder and not from a route. All right, and so that wraps up the basic introduction to Express. In the next two videos, we will talk about something called environment variables, and we will also set up ESLint in our VS Code. Welcome back. In this video, you will learn all about environment variables. So what they are, how we set them, and how we use them. Now, this is not exactly about Express. It really has to do with Node.js development in general, but we really need this in order to move on in the project. And so this is a good time to talk about this. So Node.js or Express apps can run in different environments. And the most important ones are the development environment and the production environment. That's because depending on the environment, we might use different databases, for example, or we might turn logging on or off, or we might turn debugging on or off, or really all kinds of different settings that might change depending on the development that we're in. So again, the most important ones are the development and the production environment. But there are other environments that bigger teams might use. So this type of setting that I just mentioned, like different databases or logging turned on or off, that will be based on environment variables. Now, by default, Express sets the environment to development, which makes a lot of sense because that's what we're doing when we start a new project, right? So let's just for the sake of demonstration take a look at that variable, and we're going to do that here in the server. Okay, so remember that everything that is not related to Express, we're going to do it outside of the app.js file, right? So we only use this one here to configuring our application. So we only use this one in order to configure everything that has to do with the Express application, okay? But the environment variables are really outside the scope of Express. Okay, so let's quickly do a console.log here of app.get and then env. Give it a save here, and down here you can see development. Let me clear the console here, save it again, and so here again you see development. So that is the environment that we're currently in. And so you see that this app.getEnv will get us the env environment variable. Okay, so in summary, environment variables are global variables that are used to define the environment in which a Node app is running. So this one is set by Express, but Node.js itself actually sets a lot of environments. Now this env variable here is actually set by Express, but Node.js itself actually also sets a lot of environment variables. And so let's actually take a look at those as well. So these ones are located at process.env. Give it a save. And so here we have a bunch of different variables. Okay, and I will not go through all of them, but as you see, there really are a bunch of them. And Node uses most of them internally. For example, it has the current working directory here in this environment variable, and really a bunch of other stuff, as you can see here. Okay, for example, my home folder or my login name. You see the script that we use to start this process. So really a bunch of stuff that for some reason Node.js internally needs. Now these variables, they come from the process core module and were set at the moment that the process started. And as you see, we didn't even have to require the process module, right? It is simply available everywhere automatically. Now in Express, many packages depend on a special variable called node.env. So it's a variable that's kind of a convention which should define whether we're in development or in production mode. Okay? However, Express does not really define this variable, and so we have to do that manually. And there are multiple ways in which we can do it, but let's start with the easiest one, which is to use the terminal. So I'm going to finish this process here, clear it, and so when we last started this process, we did it using npm start. And npm start, in turn, stands for, where is it? So it stands for nodemon server. Okay, and so let's copy this actually here. So we used nodemon server.js to start the process. But if we want to set an environment variable for this process, we need to prepend that variable to this command. So we say node.env, which is that special variable that I just talked about, equals development. And if I start this process now, let's take a look. And so right now we have here node.env set to development. Okay, and so this is the result of doing this console.log of process.env, right? And so that variable that we have here actually comes from that command. And we can actually define even more if we want it. So let's just say x is 23 just for testing purposes, start the process, and now you see the X environment variable is set to this 23 string. Alright? So, again, many packages on NPM that we use for Express development actually depend on this environment variable. And so when our project is ready and we are going to deploy it, we then should change the node-end variable to production. And we will do that, of course, once we deploy the project by the end of the course. So we set node-env and x as environment variables, but we can do a lot more. And that's because we usually use environment variables like configuration settings for our applications. So whenever our app needs some configuration for stuff that might change based on the environment that the app is running in, we use environment variables. For example, we might use different databases for development and for testing, and so we could define one variable for each and then activate the right database according to the environment. Also, we could set sensitive data like passwords and username using environment variables. Okay? Now, it's not really practical to always define all of these variables in the command where we start the application. So imagine we had like 10 environment variables, and it would be not really practical to having to write them out all here inside of this command. And so instead, what we do is to create a configuration file. So let me go ahead and create config.env. Okay, and so env is really the convention for defining a file which has these environment variables. And VS Code actually recognizes that and puts this like configuration icon right in the file. So let's now define this variable here and paste it in here. And we can also, well, use some of this sensitive data that I just mentioned. So let's say the user is Jonas in lowercase, and the password is 123456. Okay? Now, as you see, these variable names, they're usually always in uppercase. Okay? So that's kind of a convention that we use, right? Now, in your VS Code, probably all of the text is just white, so you have no syntax highlighting. And I have that because I used this .env extension here. Okay? So if you want your .env files to look nice like this, please go ahead and install that one. So we have user password. Let's also define the port on which our app should be running. So that's also kind of a standard variable that is usually in a .env file like this. And let's set this one to 8000. Now, how do we actually connect this .env file with our Node application? So we need some way of reading these variables from this file and then saving them as environment variables, right? Because right now, this is just a text file, and Node.js has no way of knowing that these variables are in here, okay? And so for that, the standard is kind of using a npm package called .env. So npm install .env. All right. Then let's go over to our server and actually require that module. So const .env is equal to require .env. So simple. And then down here, we can simply use this .env variable, call config on it, and then in there, we just have to pass an object to specify the path where our configuration file is located. So path config.env. And so what this command will now do is to read our variables from the file and save them into Node.js environment variables. So let's now run npm start, and that should then log all our environment variables to the console because of this line of code, right? And so let's wait for it. And indeed, here we have node-env, we have the port, the password, and of course, the rest of the data should be somewhere here inside this gigantic list. Okay, it doesn't really matter where it is here. So the user was actually jonas.io already, and so we should call this here username. Okay, then resave this here in order to rerun the server again. And so now we have a username down here. And so these are the 4 environment variables that are defined in our file. Great. And just to finish, let's now actually go ahead and use this node_env variable and also the port variable. And to do that, we go into app.js, and somewhere here the port should be defined. And somewhere here we have our logger middleware. And what I want to do now is to only run that middleware, so to only define it when we are actually in development, so that the logging does not happen when the app is in production. So we have that right here. And so let's go ahead and say if process.env.node_env is equal to development, well, only then use Morgan. Okay? Now you might be wondering why we actually have access to this environment variable here when we didn't really define them in this file, but in server.js. And the answer to that is that the reading of the variables from the file, which happens here, to the node process only needs to happen once. It's then in the process, and the process is of course the same no matter in what file we are. Right? So we're always in the same process. And the environment variables are on the process. And so the process that is running, so where our application is running, is always the same. And so this is available to us in every single file in the project. So this is how we use this variable. Now let's go back to the server, and let's say that the port should either be the one coming from the environment variables or this 3000. So process.env.port or 3000. And now something is wrong here. Let's take a look. And oh, I see I'm already using 8000 in some other application that's running somewhere on my computer. And so let me actually go ahead and change that here to 3000 as well. But it doesn't really matter. You can leave yours at 8000 if that works for you. Clear it here, give it another save, and now it works. You can also get rid of this console.log here because we don't need to see these variables all the time. Okay, and let's now quickly do an HTTP request to see if our logger still works. And I'm going to do that here in Postman again. So this one, going back, and now our logging is gone. Well, let's see why. So we have it here in development, which is correct. And so this should actually work. So this is also correct here, right? Development. Well, let's do a console.log and take a look at it here. But we do get undefined down here. So let's check what's going on here. And so yeah, so I see the problem, which is that we actually require the app file before our environment variables are read from the config file. And so it needs to be the other way around. So let me move that up here. And then only after that, we want to run the code that is in the app file. And then only after that, we want to run the code that is in the app file, right? So again, we couldn't read the process variable inside app.js because it wasn't yet configured. So if we give it a save now, then indeed you see development here. And if we do our request now, let's send it, then of course we get our logger back. Okay, so that's working now. And now finally, as the last test, let's add a new start script to our package.json. So right now we have start node_mon server, but I also want to add another one for production, just so that we can test what happens in that situation. So start prod, and so let me call the other one dev. Okay, and so in production, we simply want to set the node_env variable to production. So node_env equals production, and then the rest is the same. So nodeman server.js. So let's finish this one here. npm run start production. And so now you see that our node env variable is actually set to production. So that is coming from this console.log here. And if we now do this request, we will then not get our logger. Okay, so it's not here as it was before. Okay, and so this is basically how we run different code depending whether we are in development or in production. So let's get rid of this one here. We can close this one as well. And so let's go back to our development script, of course. So npm run start dev. And all right, here we are. Just one final test. And indeed, here is our logging result. So that's it for environment variables. Let's move on to the final lecture in this section. Before moving on to the next section and MongoDB, I want to show you how to set up ESLint together with Prettier in VS Code in order to improve our code quality. Now, if you're not using VS Code, or if you already have some kind of linter in your workflow, then please mark this lecture as completed and move on right to the next section. But if you're new to ESLint and want to improve your code quality, then let's get started with this video. So ESLint is basically a program that constantly scans our code and finds potential coding errors or simply bad coding practices that it thinks are wrong. And it's very, very configurable so that we can really fine-tune it to our needs and coding habits. Now we can also use ESLint for code formatting, but we will continue using Prettier that we already set up earlier for that. So we will set up this entire thing so that Prettier is still the main code formatter, but based on some ESLint rules that we will define. And so all that ESLint will do for us is to highlight the errors. But I know that all this probably sounds more confusing than anything else, and so let's actually set this up now. So the first thing that I want you to do is to install the ESLint extension for VS Code. So come over here and search for ESLint. Okay, and I already have it installed, but it looks like this. And so all you need to do is to go ahead and install it and then probably reload this window. And if you don't have Prettier set up yet, then go ahead and do that one as well. So this extension here, but this one we actually already did in the first section if you followed that with me. Next up, we need to install a bunch of dev dependencies. So let's actually make this here a lot bigger and go to our other terminal here. And so let's say npm install, and we need to also install ESLint in Prettier as npm packages. Okay, so ESLint in Prettier, and probably this is now the first time where we are actually installing multiple packages at the same time. And so that's very easy. We simply write all these packages all in the same command. Okay, but with these two, we are actually far from ready. So the next one is ESLint config Prettier. And this one will disable formatting for ESLint, because remember, we want Prettier to format our code. Next up, we have ESLint plugin Prettier. And this one will allow ESLint to show formatting errors as we type, again using Prettier. Okay, and all of this is of course very confusing, and I needed a lot of time to figure this out. And so this really is just a recipe that you need to follow here. Okay, so it's not about understanding what I'm doing here. All you need to do is to follow this recipe, and it will then work for this project. And in future projects, then all you have to do is to go to your package.json file and copy that configuration and install it in your next project. Because actually all of these packages, they have to be installed locally. It would not work if we tried to do this globally. All right. Anyway, we need now some JavaScript style guide that we can follow. And there are many style guides out there, but the most popular one is probably the Airbnb style guide. And so actually, there is an ESLint configuration that we can use for that, which is on npm, and it's called ESLint config Airbnb. Okay, next up, we have ESLint plugin Node, and this will add a couple of specific ESLint rules only for Node.js. Okay, so basically to find some errors that we might be doing when writing Node.js code. And now finally, we need 3 other ESLint plugins, which are only necessary in order to make the Airbnb style guide actually work. So that style guide kind of depends on these. So ESLint plugin import ESLint plugin JSX A11Y, and I see that I have a mistake here. And finally, ESLint plugin React. So even though we're not writing any React code here, we still need this one because the Airbnb style guide depends on it. So these are all the packages. I hope that I wrote them correctly. And now we need to save these as dev dependencies. So save dev, and now hit return, and cross your fingers that everything is going to work here. So it seems like it did. Let's take a look at our package.json. And indeed, here we have all of these packages. Great. Now the next step is that we need config files for both Prettier and ESLint, right? And we already created the one for Prettier before, and it's already in our project here. So it's this one, and all I did here was to say that I always want the single quotes. Okay? And the other one is the config file for ESLint, and again, it's already in the starter files, because we don't really need to waste any time simply just to write this terrible configuration file, right? So the file is already written. Let's just go very quickly through it. So here we say that we want to use the Airbnb style guide and also Prettier and also the Node plugin. Okay, now ESLint is all about coding rules, and there are many rules that ESLint tries to enforce on us. But we can actually change the ones that we want to use one by one, and we can whether turn them off completely or just showing a warning instead of showing an error. For example, one rule is that ESLint does not want us to use console.logs in our code. And so each time by default, it will give us an error when we use console.log. But instead of showing me an error, I configured it so that it only shows me a warning. Okay, so that's why we have warn. I could also completely turn it off by writing off, such as I did with many of these other rules. So for example, here in this next one, which says that each and every function should always return something. Okay, and sometimes we simply have a function which doesn't, and so I needed to turn this rule completely off. Or finally, we also have, for example, this rule here, which says that there should never be a variable that we declare but do not use. And this actually catches a lot of bugs, and so I leave it as an error here, but I also created some exceptions. So these 4 exceptions here, which are the typical variables that we have in Express, so in our handlers in Express, but that we don't always use, right? And so I don't want these to be marked as errors each time that I have, for example, a rec variable in a function, but I don't use it. Okay? So you can take a look at these other rules here and decide which one you like and which one you don't. So these ones are the rules that make sense to me, but of course it might be different for you. Let's just quickly go to the ESLint website to take a look at all the stuff that you can configure. So ESLint. Then here you have some documentation and some instructions on how you can configure it. But all I really want to show you is all these different rules. So you have all of them in here. And so you see there's a ton really of them that you can configure. Okay? So take a look at this, but actually it's easier to simply configure this ESLint whenever you get a new error in your code. Okay? So let me show that to you so that we can now see it in practice. So let's go to our server file here and simply create some code here that goes against some ES rules. So for example, defining a variable here like this, and then assigning something else to it. All right, and so we know that x is a constant, and so it should not be reassigned. So if we give this now a sign, we should actually see an error. And well, we did not. So I'm going to go ahead and close the window and then open it again. So do that as well, and hopefully it will be working by then. Okay, and so actually we see our errors here now marked in red. So we now come to this problems tab. Let me move it up a bit. And so here we see all the errors that we have. So starting with the first one, expected one empty line after the require statement not followed by another require. So basically what it's telling me is that it wants these requires here at the top, and then an empty line, and then like this, and so the error disappeared. Okay, and so this kind of enforces a nicer coding standard. Next up we have x is assigned and the value never used. And so that is that no unused variables that I mentioned before. So this one here. Okay, and so this is an error, but I could also turn it off just to show you how that would then change. So I saved it, and so now that error is gone. So you see it's no longer marked red. But actually I want this to be an error. So I write error, give it a save, and our error is back. You see, it is declared, but it's never used. And then here x is constant. So we really did an error here, which was to reassign a constant, and that is not allowed. So let's get rid of this, and then the error disappears. We still have this one because the value has never been used. Let's quickly write x plus 2, and now it's gone. But we have the next error, basically simply because we just have this code sitting around here, not assigned to anything. So let's just say const y equals this one, but then of course y is assigned but never used, and so we're entering this loop here. Okay, but anyway, this was just to demonstrate it to you. And so let's see now the final warning. And so that is the no console, right? So remember, I actually talked about this one before, and it is green because it's a warning. So again, I could turn it off, and then my problem would disappear. So the code would look normal now, but actually I want ESLint to warn me about that, because it's not a good practice to have all too many console logs later in production. All right. So it's back now, and actually VS Code also warns me that there is a green warning here in this file. So maybe you noticed that before, but if we put an error here, then actually it will turn red. Okay, so now it's red, and we have two problems in there. And that's actually really helpful to identify problems in all these files. All right, let's get rid of it. And so actually, that's it. So I hoped that it worked for you as well. If you got some error, then please try to simply install the same packages that I did. So all of these here. And remember that this is how you do it. So for example, if you want ESLint 5, just say npm I ESLint at 5. For example, you can even go 5.16.0 just to make really sure that everything is the same. And in that case, everything should work just as it did here for me. Great. So this was yet another important step in your journey of becoming a developer. Because believe me, it's really important to have code linting in place like you have now. So again, for your next project, just go ahead, copy these dependencies into your package.json file, and then install them all at the same time, and that will then make your life a lot easier. So that's how I always do it. And the same, of course, with the prettier RC and this ESLint config file. Anyway, enough talking for this video. We're now finally ready to move on to the very important MongoDB section.